All right. So welcome everybody. This is the February meeting of the Robotics Society of Southern California. My name is Ben. I am the current president, and we are here with all of my officers and a whole bunch of new faces that I see today. Welcome everybody.
All right, welcome.
This is a free and open space for everybody to come in and nerd out on robots. You can come in as much as you want. We are here on the second Saturday of every month. You are welcome to come in every meeting for free. We don't charge for anything. We don't sell anything. We normally have two lectures, one at 10 a.m. and then another one at 11. Then we break for lunch. And after that, we usually have a show and tell. Today is a little bit of a special day that we have a robot contest, what we call the Can Do Robot Challenge, where we brought some robots that autonomously look for a soda can, go find it, grab it, and pick it up. So we're going to do that after Alan's talk. So somewhere on 11-ish, we'll start the contest, and we'll go on from there. All right. So with that, Alan.
All right, good morning, everyone.
Good morning.
So this is part 2 of our group talk. Group is an NVIDIA pipeline, and oh goodness, sure, why not?
Also, for the new people, the talks are varying levels of difficulty. So there's more entry level ones varying up to different skill levels.
Very advanced.
Yeah.
We go between very beginner to very advanced.
A lot of variety.
Some intermediate.
So
Yeah.
don't be intimidated if you don't know what Alan is talking about. Just stick with it, and you'll catch up.
Yeah, that's basically the motto. Probably don't understand what's happening, but stick with it. It'll come clearer. Yeah, no problem. I'll feather all of you in a bit. So Isaac Fruit is
Can we what?
Oh,
You mean his presentation?
yeah.
You know what? Maybe you can start chasing down some of the links to put in the chat, and then as we go through,
Also,
Oh,
also the entire meeting is being recorded and it's always uploaded to our YouTube channel, so you can go back and watch them over and over and over and over and over.
okay.
yeah, we'll try to get additional information in chat that'll be posted in the forum and during break and afterwards. Most of us can make eye contact, but we're all willing to love answering questions about our pack. So,
If you have questions, you're very much welcome to stop them and ask them, hey, what the heck are you talking about?
yeah, absolutely. So, Isaac Root is the standard framework and artificial intelligence model that is the cause and the engine behind almost everything you're seeing in the recent advances in the capabilities of humanoid robotics. Alfie, the robot that's sitting behind me, was designed and built around April and June of last year in anticipation of these software breakthroughs being available. And over the past 6 months, they're not only available, but they're open source. You can download them and run them. So in our talk last month, we focused on the setup, writing the code to collect examples, how teleoperation works, and the process of collecting up as of right now 350 examples of the behavior that I want to train them on. And that's divided into 2 categories. The first prompt is find the can and pick it up, and the second prompt is put the can down. So I have about 150 of each, and showed how we captured that and how we translated that into a format for fine tuning, and that's where the talk ended last month. Coming into this month, and something in the range of 60 commits. Actually, I'm up to 80 commits later as I attempt to write the code and close the gap to get it to do the thing. You'll see where I ended up this month and for the contest. I also developed some tools to make it easier to manage those episodes. There's one of the main ones was just to make it easier to navigate all of these episodes and how to tag them and how to edit them. Take a look to see what the recording looked like and then possibly to delete them as well. This was huge. This made the last half of the training go way faster than the first half. So after I fine-tuned, and this was at 75 examples of behavior, the fine-tuning process took about 10 hours on my home computer. And I'm like, okay, that's not so bad. I could do some things during the day, kick off this fine-tune to learn the behavior overnight, and the next morning I can jump in and see how it worked. That was the game plan up to a point, and when I did that, here's what I ended up with. So the mission parameters, every episode was trained with the following behavior. Look around, find the can, and center the can in your field of view. Then turn the body to face the can while keeping the can in center of view. Approach the can to where the can is about a foot away, a little bit off to the right. Then to reach out and pick up the can and hold it to the center of your chest, and that is the end of the behavior. That was recorded 165 times. But when we play it back, we're not seeing that. Something's not quite right.
Dance. It looks like the wheels are off the floor.
Right? I did design and print a stand so I could test this out without having to chase them down and reset it. And so we're not seeing a sequence of behaviors. Something's not quite right. Now, I'm the first person to admit, and I'll remind everyone from last month, I haven't written really any code in the past 3 months. I've been partnering with Claude Code to write the framework, to troubleshoot, to test. And what that means is I've gone from a developer type code writing role to a project manager, business analyst, architect type role, right? Those are the things that as of right now, Claude Code doesn't do well. And we've been working really well together. However, after the first foray into running the code on the model, there's a bunch of things that aren't right. So when you look at all the things that could have been wrong, right? This is, to my best understanding, the probable solution state of things that I might not have done correctly. Now, first off, in spite of the fact, now you have to feel bad for the guys. NVIDIA is like a $4.5 trillion company. They just don't have the resources to devote to having accurate, up-to-date documentation of sample code. And I can appreciate that.
Jetson should do it.
And I'm talking from simple stuff like having the wrong format for the command line arguments to missing or not including sections of code. It's embarrassing.
I can vouch for you. The NVIDIA stuff is horrible. It's really bad.
Yeah, all the docs, trying to get it working.
So they didn't even have a chance to say it.
Right, which is totally surprising because this isn't some pet project. If you listen to their keynote speech in CES, robots are the future, but apparently not enough because I'm dealing with simple stuff like that, and it does trip me up because I only pretend to be a developer. So between me and Claude, we figured a lot of that out. So the rest of the things that maybe have resulted. Not enough fine tuning. So you have your example episodes, and then there's a training process where you train it over multiple epochs and training steps. The example code said after 2,000 steps, I should have it. Maybe that's not enough. I still haven't validated that yet. We'll get back to that. Maybe there's a problem in my conversion script where I convert my ROS bag recorded episodes to the correct format for fine tuning. Maybe there's some problems in the group configuration. There's some very finicky setup in 3 different files that all have to match. And they all have to match with the training script, the conversion script, the fine-tuning script, and inference. There could be some problems there. I burned a couple of days seeing if there was a difference between the MP4 video that was used in the training runs and the live video that was available to the robot. So the whole fine tuning process involves capturing video, and that training process captures it to MP4, and then it's transcoded into another format, which may or may not match the characteristics of the live video. That could have been something that was wrong. A lot of time was spent, and we're going to revisit this in the code in the client and server protocol. I vibe coded the complete client server stack with foreshadowing. There could be some problems there. The model is trained on relative actions. However, when you get back to the real world, they have to be absolute. There could be some challenges there. When you fine tune to a specific video FPS. Maybe there's some misalignment between me training at 15 FPS and the live robot being only 2 FPS right now. Yeah.
What is absolute versus relative observation? I mean,
So the input to the fine tuning model for my regime is absolute velocities for the base. However, I record the absolute positions for the arms and the head and the back. Now, as part of the fine tuning process, that's abstracted based on the stats file to actual fine tune on the relative positions. And if your normalization denormalization portion of your client script doesn't take that into account, you're going to have a bad time. Anyways, trying to figure out if I got it right.
Which relative, in other words, from the robot's point POV,
Yeah.
it's relative as opposed to
As part of the training process, it looks at your min and max joint values for every joint, and then it records that in your stats file. And then what goes into the fine tuning is some relative
So those are
measure.
delta or like a percent or something instead
Something
of
like that, yeah.
But is it also deltas like move 20% this way, then
-1, +1, or 0 to 1 based
But
on.
you're just
it's all normalized
it's
ranges.
normalized ranges,
Yeah.
but it's still absolute though. It's not relative. Relative would be like move the delta. You know what I'm saying?
Yeah.
But you could convert to deltas.
Yeah, it's making sure there's not some misalignment there. And none of this was taken into memory, just
We
to
don't know.
share with you how much I could have done wrong. Right. Every time you evaluate, it spits out a 16-step trajectory. Maybe there's a misalignment between how I'm using that. There is a substantial challenge with their fine tuning steps to produce a TensorRT compiled engine to make it run faster. Your MSE, MAE, your mean squared and average errors go up by a factor of 100 on their instructions for fine tuning the engine. That threw me for a loop.
From you could go up the factor from what was the earlier one, what was
Yeah.
the other one? I mean, before you use the TensorRT, when you just use
You can run it. You can run the model off of PyTorch, and I get some amazing average error numbers off of that. You use the TensorRT engine following their instructions, and it is 100 times worse.
But usually TensorRT is just for inference.
For inference. Yeah, the inference version.
You don't get an error when you're in.
Oh no, it's 100 times worse when you use the TensorRT version for inference versus PyTorch.
Oh, I see. Both inference. You're looking at the error. Oh, so you're comparing an inference to the ground truth.
PyTorch inference versus the TensorRT engine inference
against the ground truth, against some ground truth,
Yeah.
then you're getting 100 times.
Yeah.
That's
Following
not
their
cool.
instructions. That was disappointing. I also, hardware-wise, I've got shoulder oscillation harmonics because there's 2 motors that are supposed to go to the same position, which I characterize as a twitch, which is not supposed to happen. And foreshadowing, did I even bother to look at any reference implementations of the client server code? No, not until 9 p.m. last night. We moved back to that as well. So, things that I've confirmed that I've addressed are in bold, are I suspect are in bold or want to follow up with. So after about 2 months, maybe I should read the directions and and see what I might have missed. And something really stood out at me. I want to scroll down, scroll down, scroll down. Group 1.6 is intended for researchers and professionals in robotics. Oops. So I'm obviously in over my head. Claude is way smarter than me, but there's a limit. I've mentioned multiple times in the past. Large language models are trained on a universe of tokens and numbers and language. Current generation falls short because they don't have experience with the real world. The physical robotics and all the stuff that they're doing is going to close that gap. But what this means is I can't trust Claude to fix everything. It needs my intuition to figure out where to look and to help characterize that in a way that Claude and I can figure out. So where do we start? Where do we start? Sorry, we're scrolling a little bit weird. Okay, now as part of their how do you do the thing tutorial, they have a standalone inference script. There's no client server code. It's all written in Python. And this is your first hint to see if you're doing a good job or not. And as part of that, it produces a couple of numbers. MSE, MA, mean squared error and mean average error. You may be wondering what that means, why it is important, how to interpret it. These are all great questions, and Claude will tell you how it's calculated and how to interpret it. But this doesn't tell you, based on their existing documentation, if it's a good model or not, because they don't tell you what adequate numbers are and how those numbers may loosely reflect on real world performance. So at my 2000 step run, I was getting an MSE of 0.04, and I was getting an MAE of 0.1 at that time, something like that. And I'm like, okay, that doesn't sound quite right. Ryan, you're right to grimace. And so the question is, what do you do? Which one of these things do you address to see if it makes a difference? Now, not enough fine tuning and number of recorded episodes were the two things that I could affect. So Danny was kind enough to come over a bunch of times to record our current total of 323 episodes. Right?
We recorded way more than that over the lead.
Right? And getting back to the quality, as I got better at teleoperation, the quality of the episodes we were recording increased drastically. But running short on time, we didn't go through and prune the first 100, but that could be another thing to look into. So the other thing that I wanted to explore is fine tuning. Now it took 10 hours to record 2000 steps. Now, when I went back in RTFM, I noticed that some fine tuning scripts had 10,000 steps, which takes 2.5 days on my box. I didn't have the patience. I was out of time. So what's a boy to do? Except to, oh no, where's my screenshot? That's the wrong screenshot. Hold on, let me see if I can find the screenshot.
Did you like do it synthetic?
There is a wonderful company out there called RunPod. And RunPod will sell you access to clusters.
Why don't you throw money at it?
And yeah, throw money at it. A cluster is some big iron that will run your jobs for a price, a lot faster than I can run them locally. And I'll see if I can find a screenshot. I have a screenshot of, hey, come on in. It's okay. Yeah, come on in. Grab a seat. We got one right there and one right there.
Here,
Yeah.
I'm gonna set some rows.
Okay. So I threw a couple of bucks at the problem.
Here.
And we can put on more chairs.
Oh, yeah, wherever you're comfortable. Okay. You can take a room. And I was really hoping to get an 8G cluster of check really quick to see if I can find. Here we go. Let me go ahead and get rid of that, and get rid of that. I was really hoping to get an 8 GPU cluster just to see, and they charge like, trains in half the time cost like, cost the same amount of money. I was only able to corner a 4 GPU customer, so a GPU go burr. This machine is consuming over 3,000 watts of electricity, and it churned through my 56-hour fine tune in 4.5 hours.
Nice.
So well worth the money to just cross that off. And I grabbed checkpoints
That's why it's
at
warm in here right now.
2, 4, 6, 8, and 10,000 steps. So I can go back through and characterize the behavior of the robot to just figure out what the minimum is on that. So I'm not blowing 3.5 days every time I get the thing, right? So now I have the tools to at least figure out how much fine tuning.
This is like one of those cases in programming or development where you really want to carefully control your iteration loop, right?
Yeah.
Like in programmers, how many times I hit compile when I change it? When you're at the end, you're like 50 times an hour. You don't want to do this 50 times.
Yeah. Sorry, I keep the scrolling is weird. Right. So now I have checkpoints. I've got a 10,000. That's going to be the best in breed. It's still not doing the thing. So what else could be going wrong? There's another evaluation that they've hidden on another one of their pages. This should be part of the tutorial, but it's not. It's called open loop eval. And open loop eval does a similar thing as the previous script, but it provides some graphs to help visually understand how well your model is fitting. And the beauty of this is that what the script does is it takes one of your recorded episodes. So the inputs to the script are your recordings from one of the things you trained it on. And it plays that recording back, and then it overlays the inference results from that recorded episode. So it is stacking the deck. It was trained on the data, but it helps to visually characterize if you have enough fine tuning. And what you're seeing is a beautiful correspondence between a predicted action and the recorded action in here. And so just on the first graph, velocity LX is me turning to the left to face the can. And so we have a graph for each one of these actions. And you can see a beautiful low noise correspondence between the recording, which is in red, and the neural model's output, which is in green. The one down below, don't worry about this. Look at the scale. The scale shows very good correspondence, but because the scale is plus or minus 0.006, it looks noisy, but it's actually not. Scrolling down a little bit more to something like the shoulder Yakimir, you again see a very high correspondence between the recorded action in there. So what this tells me is that the model is very good, right? And this was the hard part. Do we have a model that is adequate and appropriate to solve for this? So for me, the hard part was done. We fine-tuned the model. We're proving that the model is good enough. Why isn't it doing the thing?
Yeah, Alan, when you're saying those, when you see these graphs that are where the model's predicting and it's matching, what is that inference like? What was the input to that? In other words, how are you prove? Why is this relevant exactly? As far as what was the input and this, because this is the output, right? These curves are the output movements. So the input was the video of the can there, right? I assume. And then, but yeah, like when you're trying to do an inference, this is all in simulation. So there's no video, there's no like real can there, and you're not moving in an environment even in real.
Yeah.
So how does it even create that? Graph?
Good question. It's actually replaying episode 0 as inputs to the model.
Episode 0.
Yeah.
So there's no simulations. He's recorded his trainings And he's taking different parts of his trainings and saying, well, what would you have done at this point? And seeing if it matched what he did at that point.
But I mean, does it, the thing is, if you're giving it what you did, how does it have to be a, you know, something ahead so that you're not giving the model the answer already?
Yeah, it's just replaying the reporting back, and it's measuring the output from inference, and then at MSE is comparing the inference output to the ground truth of the episode.
So you're showing the video that you actually did a capture, and you're asking the model to, at each frame or whatever, in each iteration, what would you do? What would you do? Even though the video is doing the right thing.
Exactly.
So it's not quite a perfect test.
It's even more than that. So if I got this wrong, that's what I understood from you, is you show it the picture in the drawing state and say, what would you do? And what would you do in the next 16 time steps? So it's looking into the future.
Okay,
I do this, and I do this, and I do this.
So you are looking ahead without giving it the next frame. Or without
The model provides a 16-step trajectory horizon, and it's up to the client to figure out how many of that you use, which we're going to loop back to.
Oh, the client has to decide.
Yeah. So,
Okay, but
yeah,
in other words, there is, you're not
it's
giving,
not
you're
perfect,
not giving
but it's a
the
great
full
first
answer
start.
to
Yeah.
it, but you're not actually, but you are getting something.
A quick and dirty characterization of the quality of the fine-tuned model. And now that we have a visual aid, and I need to submit some PRs to them because someone's got to pay attention. This should be in their tutorial, because this is far better than the one they have now with just for the NSE NAE.
Yeah.
This is amazing.
This was not, you had to give this yourself.
I cried with joy when I saw this. I'm like, oh, the model works. Like, right? One less thing to worry about. Until, in the interest of time, I have enough material for 4 hours. We're not going to do that. As you can see, a lot of, okay. Okay, going down the list. I wrote a server radio visualization tool that shows me exactly what the server is receiving, so I could make sure that it was getting the video and if there's any latencies or delays. I also worked with Claude on something we're calling hybrid image test, in which we'll set up the robot in the same starting conditions, run a couple of frames from the recording to characterize the behavior of the model, and then use an image from the camera, and then run a few frames of it to see if we can do a difference. And this threw me off for a couple of days because it was suggesting that there was a problem in the image pipeline, that there was a qualitative difference between the exported MP4 video file that went into fine tuning with the video images that was used for live. Turns out didn't make a damn bit of difference, but it took a while to figure that out. The other surprise was the PyTorch versus TensorRT model. In their tutorial, they talk about generating a TensorRT engine for the model that can run faster because it translates the model into code.
Yeah.
And there's not supposed to be a performance delta, but when I run that open loop eval, which I also had to write the code to extend the open loop evals to support the PyTorch version of the engine, because why would you do that? The performance of the TensorRT version was 100 times worse than the PyTorch engine. So after we figured that out, and I moved back to PyTorch and a whole bunch more troubleshooting, we got to the first success. And it's not pretty, it's not great, but there was some cheering when this happened. So we're seeing one behavior I'm calling the mantis behavior. Have you ever seen a praying mantis that oscillates back and forth as it approaches a position?
Oh.
Getting back to Brian's point about the action horizon, you send a packet, which is your video images and your current observation state, your position of all your joints, and it generates an inference output with 16 trajectories, and so there's a lag between where you send it, you get the set of actions back, And how do you deal with it? This is all code at this point. We've proven the model works. Now it's the client server code to make sure that we can execute on that based on right now doing 2 observations per second based on your AGX. And that's one of the sources of this mantis behavior that you're seeing. But we're getting close, right? So far, so good. The other thing was there was something that came up that I'm calling emergent behavior, but it's actually not. It's a combination of a fine-tuning and underlying model. And that is, I came too close. That was bad. And at this point, it can't find the can. So it's reverting back to its other fine-tuning, which is a behavior of looking around for the can, which it's doing.
You're gonna have a hard time finding it.
He'll never find it. But we never trained for this eventuality. And it starts turning around looking for it. I thought this was so cool. And of course, he never finds it. But this was never in my fine-tuning data. So I'm calling this an emergent behavior because it, and then now he sees it and it's like, ah, it's in the wrong spot, right? How cool is that, right? So I had to capture that. So where are we at right now? Remember my foreshadowing. We vibe coded the entire client server architecture without referring to the reference documentation. Around 9 p.m. last night, I had that, there should have been a thing there. We'll go back to our list of stuff I could have done. For some reason, all right, nope. Can I go up? Let me go up. Did you even look at any of the reference implementations of the client server code? I was hitting a dead end in troubleshooting. Oh no, where's my troubleshooting? Okay, yeah, here's my troubleshooting. Nope. I went through 34 iterations last night. The first 20 were here we go, testing runs. There's 40 of them. So every time I made a change, I captured it in a git commit and I captured what changed and I characterized the output, right? 19 times last night. After the 19th time, I'm like, hey, someone else has already should have written a reference implementation on how to do this. So I'm like, Claude, let's look through the Git repository to see if there's a reference implementation. Yeah, there was. We didn't even look at that. So we came up with a refactor plan. Claude's nothing if not direct.
Versus greatly. What is it?
Right?
Versus significantly.
Right. So at 9:10 last night, it had a git commit for my previous code as a fallback. And I'm like, Claude, take the wheel, do all the things, follow your intuitions, look at the reference implementation, and we'll try that. So test runs 20 through 39 or so were based on the new one. Now, and while we've made a lot of progress, here's where I'm at right now. I would have loved to have a perfectly behaved thing in there, but we're not there yet. But the things I need to look into next are to continue to look at the client server implementation based on the limitation of 2 observations per second and the lag of 500 milliseconds and what to do with the trajectories in there. There's a lot of work to be done there. I still have some questions about the 16-step trajectory with respect to the FPS and the fine-tuning. And I think it'll be based on where I need to end up. I think with code optimizations, I can get 4 observations per second. I also believe that the fine-tuning needs to be run at whatever that FPS is to get better trajectory normal averages. Claude tells me I'm wrong. I still want to explore that.
Seems like their refresh rate is really critical here.
Yeah, and that's what
these highest plus.
exactly, and that's what we're seeing right now is
Sampling rate can cause oscillation.
The thing is, in reality, you'll never have a 0 latency inference and 0 latency everything. So
Nothing.
there's going to be some latency. So the hard part is how to deal with that latency, how to train
Yeah.
for it, how to react to it in real time. So that's
I mean, that's an exercise, but if you could get higher, you know, frequency, it's.
Oh,
make
absolutely,
everything
more hardware is
easier.
the problem. So here's
Gonna make
what
it
I know.
easier.
And here's why this is, and like, oh, that must suck, Alan, because you're not, no, this is amazing. Here's what I know. My model is almost perfect. We can see that in open loop eval. And that open loop eval was run through the client server code. It wasn't run locally. So I know I have a great model. I've also, day after day, I see YouTube clips of humanoid robots exhibiting behaviors that are smooth and in real time. And okay, so they're using Thor and I'm using an Orin. I can run the code on my 5090, which is still 5 times faster than a Thor. So I know there's a solution space to where this works, right? So I'm very, very, very excited.
Now, when you say client server a lot, and I'm a little not clear on is the client is the actual robot? I mean, it's actual, the Orin AGX or, you know, and is the server, or are they both in the.
They can be. The reference implementation uses a client server architecture where observations and actions are passed over messages.
Okay,
And
so
what
that's,
that means is it decouples from where you need to run the server. So I run the server on my 5090 at home.
okay.
I'm running the server on my Orin AGX. Yeah,
So you got one too.
yeah.
And there you have
I
it.
really wish I would have known I needed one when they were on sale.
Oh, right. Okay, you got it, but you got it.
Right, so I know this is solvable with this hardware, with this solution. It's a matter of figuring
So
out how they did it.
So that you collect the data and you know, the client is collecting data, sending it to the server does some crunching, then sends back trajectories.
Yeah, and
It's nutshell.
so I know it's solvable. I know it works. It's just a matter of figuring out how. So in spite of the fact that it's not working great right now, I know it's going to. I really wish I would have spent more time figuring this out before the contest, but it is what it is.
Oh,
So to wrap up, I've got 2 more videos, and you're going to see this during the contest as well. This was run 9 on the vibe coded client server code, and I can't even remember what the outcome was. We'll relive it together.
What happened? Did something get you to that last
You
one?
know what? Maybe I'll revert back to this code build for the contest. So, and the icing on the cake was my one more thing was follow up command, put the can down.
Say happy day.
I work so hard and you want to put this thing down? Come on. Robot
All right.
slamming the tequila when you fish that.
Dogs looking awesome. So to wrap up my talk for today, as we start preparing for the contest and our continuation for part 3, what's the next step? I have a whole game plan for Gen 2 hardware. Now, among other things, and there's a bunch of words on this list, but I installed the mechanism wheels incorrectly, so I need to fix that. There's an arm upgrade. You're seeing 2 behaviors in the example. There's the mantis behavior where it's repeating sections of the behavior over and over again. And there's a shoulder oscillation because of the shoulder architecture. All that's going away. The arms are going to have 2 more degrees of freedom. They're going to be stronger. I've got a version of the hands I'll show you in a second. Let's see over here. Do I have it? Am I logged in yet? Just to briefly show what I'm up to. I've got a sketch of here. So there's a new version of the arm. This is just a very rough draft. 2 more degrees of freedom. Will be a lot stronger with no wobbling. And I'm modifying a version of the amazing hand to be smaller with 3 fingers. That I've already ordered most of the parts for instead. So I'll start working on that next. And hold on, That Orin dev kit that I bought thinking I needed it to fine tune. Why on earth would I buy higher quality hardware and not install it on the bot?
On the bot, yeah.
There's a new version. I've already designed the base floor where the Orin goes there and the buck down converter goes inside, along with the arms and an upgraded mic and IMU that I ordered. The arms will be able to pivot up. They'll actually have a third degree of freedom in the shoulder to reach onto counters. So he'll be able to switch between the Crichton configuration of Buck Rogers fans and the Mantis configuration, like you're seeing in the Aloha platform.
Crichton is the,
Crichton from Buck Rogers, the obnoxious robot.
yeah, but what did
tall.
it do?
Oh, he just had normal arms. He was just like
Yeah.
yeah. So a lot of things coming up. I'll be developing the Gen 2 hardware in concert with proving out some of those hypotheses and questions we have about the next steps. But I got to tell you, in spite of the fact that it's not working great right now, all hints are that I can get this version to work better. And once we can figure out that client server lag Mantis thing, I'm going to spend the next 6 months in teleoperation having them do things all over the house, because the platform is proving itself to be capable for generalized solutions to things you need to do right now. Not to say that it's not complete. There's some higher level stuff you need to do. You send it a command to execute a behavior, it executes that behavior. That doesn't say anything about planning or scheduling or text to speech or verbal commands. There's other stuff you bolt on top of that for now. But man, what a fun couple of months it's been.
Your dog is gonna love the next 6 months.
Oh,
She's gonna
did you
better at it.
did you see one of the? It's so funny you mentioned that. My great Gracie, none of my Great Danes have been fond of anything that moves. She barely tolerates the Roomba, and I'm surprised she's sticking around as close as she is right now. And in addition, the can has weights in it, so it rattles. And so she's hard no. If this thing is up and running, she is nowhere near it. So as we wrap up for the contest,
Dog luck.
yeah. I'm going to revert back to the pre-reference implementation code. It's going to be a one-off. There's also a chance I won't be able to get this run for the contest. I will try my hardest. And I'm very excited to continue the conversation next month with wherever we end up. So, all right. Thanks for your time.
Thank you, Alan. Okay, just some little more announcements. For those online, if you have a show and tell, let me know so I can add you to the list, as well as for everybody here. If you have a show and tell, let me know so I can add you to the list. The way we're gonna do the show and tells today is that after the contest, the contestants will do their own little show and tell about their builds, and then after that, we'll do the show and tells of everybody else. Okay? But again, let me know that you have a show and tell.
One more thing. So last meeting, I announced that the 908 magazine said that they would possibly publish. So they replied to me saying that they'll post it online, our article and our pictures. We'll take a couple, maybe group pictures or something like that. And then if there's enough clicks on it, they put it into the magazine. So that's the trick. So I don't know what the click number is or anything, and it might be interesting just from their own perspective, because they never have robots in there. They always have bike rides and things going around Long Beach. So anyway, I'm just letting you know that if you don't want to be in the picture, then I'm just letting you know we'll take a group picture for everybody here. But if you don't want to be in it, just don't be in the picture or whatever.
And then we'll all go into the online article and click it.
Yeah. And then okay, and then for my robot, when we do my robot, I'm going to have people with all the bright colored shirts because I'm looking for red. That might show up. You guys left me on that side of the.
Was that on purpose?
I'm finding out new discoveries today. So
Yeah, not a
the lighting is weird outside. It's getting in the windows. So
So let's
Yeah, we don't want,
initial, list in order. I do need some setup time, so if you put me towards the end, I would appreciate that.
Sure. Okay, so,
Propose the contest, so perhaps I should build.
You want to start?
All right.
Excellent. Perfect.
okay, hold on. Let me see.
Oh, and we need our videographer to be set up for remote.
So are we doing it in the hallway?
Okay,
We will support the contest in here or out there, wherever you're most comfortable. It sounds like.
Yeah, I need it in the hallway.
I'm checking mostly.
I'll see everything in this room within.
Who's gonna be next after Jim?
The same here, but they just moved everything. We gotta get a radius over here. But
John.
that's good.
Yeah,
You wanna be next after Jim?
for what?
After Jim?
For what?
It's
Yeah,
not-
I'll go, yeah.
Okay, so John. Who is after,
Sure.
Brian?
Yeah.
And then Carl,
Then I could go.
and then Carl. And then, oh,
I have a really fast reflex.
Jim, Dee.
Yeah.
My robot is outside, one
Tenth
of
of a second.
my students is,
It's gonna.
participating with, so I'll put MJ there.
Okay.
Okay, MJ, you're after Jim Denuzio.
You can just have the video. We have a video.
Anybody else? Oh, Walter.
Okay,
All right.
Maybe. I don't know if it's working.
Anybody else?
Perfect. I'll hold up the
It
rear.
worked at home, that's all you know.
Alan.
I recorded multiple videos.
All right, so
All this time.
the order is Jim Kubersetsig, and then John, then Brian, then Carl, Jim Denuzio, MJ, Walter, and Alan.
You have me, I'm Bob, not John, you have John in there too?
Oh, he just said your name.
Oh.
I was like, I'm second.
Oh, okay.
Is there anyone online?
That's a
I
question.
know they don't.
Yeah, there's Michael, that is available to do,
Oh, yeah, so,
Online.
okay, so,
Yeah,
Michael, online.
yeah.
This is because we're all in here.
How about if you're gonna do a can do online? So I'll put you after, the last one, and when we come back in the room.
Is he set up right now? We could do it right now.
Oh, Michael, are you set up right now? So you-
Yes, sure.
All right.
That way we're all, yeah, we're all.
Yeah. All right, Michael, take it away.
All right, let me see if I can find the right thing. Let's see. Let me know if,
And Ross, I'll put you first on the show and tells after the contestants.
are you seeing my RViz display?
Yep.
All right, this only takes a minute. If I can find the start button here.
So it's a screen saver.
Oh,
Let's see.
For those who didn't see the discussion online before, what Michael Wimble has done is way beyond our context.
Yeah,
His room actually goes through the house and finds the
Well, if I can find a way to make it play. Come on, play.
I see the little play button at the bottom.
Yeah, the problem, let me take it out of full screen mode and see if that helps here. Go back here. And do you still see it?
No.
You're not sharing screen.
Oh, let's go back to share again. Share this. How's that?
Yeah.
Okay. So let me go back to the beginning. So my robot is so this is RViz window. I'll explain the window, then play the thing here. So in the lower left, there's two videos, or two camera displays there. The upper one where you see the chair is the Oak D camera at the top of the robot looking down. The Oak D is doing 3D depth and also 2D object detection. The lower image you see is from the Pi camera sitting right above the gripper on this thing. So this thing's all going to be driven by a behavior tree. So I'll explain quickly here. The behavior tree is going to, after it starts up, does its safety checks and all that sort of thing. It's going to look in a database to see where soda might be in the house, and it'll pull the first thing off the stack, which says that, oh, I think there's soda in the computer room. And it's going to plot a course to the computer room, try to get it close to where it thinks soda might be. Then the behavior tree will use the Oak D camera to look around and say, do I see a can? If so, try to get a course position toward the can. Then the behavior tree will turn it over to the Pi camera, the lower one, which will then say, so the gripper is mounted on a two-axis gripper. There's an elevator and an extender. So it'll raise the arm up along the elevator until it thinks it's at the height of the Coke can. Then it'll open the gripper, extend it out, grab the Coke can, raise it up so it doesn't drag it across the table, bring it back to a safe position, then return to talk to the invisible man sitting in the chair here. So here it goes. If you're familiar with what RViz does, you can see it all going on this. So this is real-time speed. This thing moves right along here. I've spent a lot of effort making this thing move fast. You'll begin to see the AI detection bounding box annotations there. Here it's raising up. It's precise positioning, grabbing the can, lifting up the can, bringing it back, putting it in a safe position to travel so it isn't top heavy on the robot. And it's going to come back to the invisible man again to hand him the can. So this, as you can imagine, is a lot of long hours to get this to work. And just yesterday, I finally got it to move all the things smoothly.
Wow, looks great. That's amazing.
Okay. All right, that was it.
Knocked it out of the park, my friend. That is amazing.
Extra credit, huh?
That's extra credit right there. Oh my goodness, Alan, you got a competition.
Yeah, you cooked.
All right.
All right, want to go home.
All right, so Danny, you will be the judge, and
I don't want the judge, I want the can person.
oh, who's gonna be the? Who's the camp person
everyone
who's
mad
the
at
judge?
Someone
So
is
it's not
going to
gonna
do
do
the
this not
timer.
much.
Yeah, it's
Can you do that?
Yeah.
Okay, try it.
We trust you.
Okay,
Mad at me, coming after
Danny
me.
is the judge. So Danny, did you decide if the robots are gonna start facing away, facing forward?
I'm thinking like, an angle, like, kind of like to the side, slightly side back.
Sounds good.
All
So,
right, so pick, an angle, from front clockwise, so 15,
Like
30,
100.
45, 90.
Shall we?
Okay.
So he's the video
ready?
videographer. So you're gonna start taking over this screen. And then,
Yeah.
and then we're all gonna go outside?
Yeah.
Okay. Now we need to.
All right,
All right.
Seth, are you logged in?
all right, Seth will be the camera person.
Fine.
Should I turn my microphone on since we're leaving the room? Yeah.
Yeah, I'm gonna mute in here. All right, so I muted and turned down the volume in here. So yeah, you can join audio. That's perfect. I want to watch everything. It's still fair.
I think you're getting close on your first card. Yeah. Some of them.
Oh, your platform is
a little bit. Yeah.
Yeah. That's
I know. The direction.
Hey, Mr. Thomas.
You made it, yay.
Next month.
That's right, it was recorded, so.
I wanted something compliant and somewhat sticky and. I don't know.
Yeah, because I was also.
Yeah.
Oh, Ben, if you got your laptop, did you want to capture the times for Dan?
Other people have like.
Okay, sorry, I'm overnight. You guys got it.
That works too.
Okay, so
But I
how,
can never, I don't even know what
so like, you want it to be like right there? Okay. So we'll do a foot for everyone. Does everybody agree we'll do 1 foot at 90 degrees?
Sure.
Okay.
Or in my case, it'd be a little. From the farthest point of the robot, my arm sticks out that far.
Okay, I will start the timer as soon as the robot starts moving. Okay.
I need to have it squares, but
When it's being recorded, so I can start the robot.
It's sorted. It's recording.
Okay, ready? I'm ready with the timer.
alright.
So as soon as it starts moving, I'll start the timer.
Yeah.
Yeah.
Yeah, I'll do the.
Victory dance.
Nice. Can't clap.
All right.
I want to.
Oh, do you want to do it 3 times or?
Okay, so the contest only required for you to grab it and pick it up. So after I picked it up, that's where I stopped it. I didn't record the rest of it. Well, I just had to turn on the power switch. That's all I did. I know, but.
No, he's just saying he gave you a shorter time because the second you picked it up,
What's
the timer stopped.
Yeah, because the contents and shit, grab it and pick it up.
Oh,
wow. Yeah, to do that, I stopped the timer. Myself. So, Jim, you had a time of 11:51 seconds?
Yes.
Okay. Who's next? John.
Or Bob.
Whoever's going next have their own can or we borrow yours?
No, I have a full can.
Okay, so I'll give you your can back.
That's a big can
Oh,
too.
he's so cute.
So we took, so the red is facing, I'm using the color camera, so.
Okay, so you
So-
said something about,
Yeah, this is the camera, so if any of this, in other words, don't have the white label.
okay, so you want it 1 foot from his arm?
Yeah, you can put it anywhere on this side if you want. He'll do a full
So it
rotation.
could be like 1 foot from here,
Yeah, you want, yeah.
like that?
Oh, wait, let's see it. The arm might hit. You can do a little project. I'm just making it so I don't misjudge the walls or anything. Oh, it's not, we got all the wrong colors there.
Oh, I'm sorry.
That's all right. Okay. It's a color camera that has trouble with the lighting in here. That way is really bad over there, but we have people blocking the lights, so it shouldn't have any trouble then.
All right, again, I'll start the timer when the roll flies.
Okay. Make sure this thing's not a nut. That's the right.
Oh. Okay, that's try one.
Yeah, I'll have to close the call more.
So you got it right.
I didn't want to pitch the can.
Do you want a lighter weight can?
No, I can do a full can. It's just, what I need to do is first readjust the fingers.
Okay, so you got 3 tries.
Yeah, here, let me first,
Oh, yeah.
close the fingers on it. This is just to get it so that I have the fingers. I made it so it wouldn't pitch the can.
Yeah.
See, it's holding the can. I'll have my line open all the way. There. Yeah.
You said you want it a little bit like.
Yeah, it doesn't matter. Yeah, it's,
Facing right way.
yeah, but I think that's 3 feet. It looks like it'll probably be when it's done.
It's like, yeah, from here to here is like.
Yeah, but if this is the one that's measuring, so it'll spin around, it'll probably be about right. Okay, so. I have it also blindfold mode, so the camera didn't work. Working on the one.
Yeah.
All right. That's about the heaviest can. That's the full size. It can't be much more than that. Yeah.
Oh, there's a strong.
How are you? Great.
This arm will do stuff too, but for the contest.
Doing well.
Do you want to do your third try?
What's that?
You want to do your third try?
Yeah, for the other arm.
Knock me on my butt.
Yes,
Yeah,
I just
I'm
were. So like, it's gonna be the average of the three or the best of three.
Okay.
How's this guy going?
Good, made a lot of progress. I know it'll work. I just need to figure out the client service.
I was thinking I was gonna try to make it so it back away from the can. It was too close, it would knock it over. That was too much work.
So,
The real world does have challenges.
yes.
So this
yeah.
is without the
Virtual
red
world
cap
is a
on.
whole lot easier.
Or without the color cam. But the color camera has 7
Pick up a
colors.
Coke can?
We will see.
So what is the sensor on the camera?
There's an
It's
earlier
just
version of the
it's
software that
ultrasonic.
Ultrasonic.
I still have that earlier version.
do the same performance.
But
You're working on it,
Yeah.
Sorry, maybe I should not
With the
interrupt.
camera,
Oh,
I
no,
can
that's okay.
I can move the
I've got all
camera
the right
around,
time.
the camera around while it's tracking it and go try to
and
find
as
it.
long as I have the
That was
previous
your
documents,
fastest.
I can revert to
I was
a
like,
appropriate
that's
bill,
it.
let's say that it sounds like a whistle thing.
Okay.
Awesome, great job.
All right, you want to see the other one? This doesn't have its content, but this is the other
Yeah,
one.
just for fun.
Yeah, I don't know how good it'll
I've
work
been
on the
going
floor.
driving neck
but
deep
we'll
in
see.
AI these days.
The floor has a little bit of grit on it, so we'll see how it does.
Oh, yeah?
Oh, wait.
All right, so what's
I
going
got
on?
faith
Yeah,
in this
you're posting a lot?
Yeah. Well, I finally got my head wrapped around, large language models now.
Oh, it's not gonna be able to pick up that heavy can. You got a regular can anywhere.
Oh, okay. Okay, what do you mean by accent model?
They won't be able to pick it up.
Well,
But
it might also be that big of a robot, I suppose.
Good swap.
Information.
That
It's coins in it.
Yeah.
Isn't it
Instant model from Root? I think everyone's doing some variation of the same thing.
That's awesome, great.
Yeah.
That was even faster.
Well, it's up to you, but yeah, that one,
Those wrong
yeah, it's up to you what you want to do.
Oh, from scratch? Okay. That's not bad.
Pick it up before-
Oh, okay.
Yeah, well, people have already done the research, they think it's a path to get there. You follow the path, and you get there. I'm assuming, you got the path. I'm not there yet.
We're doing like one.
I just do it. The great thing about AI, AI can teach you about AI.
Yes.
And it's very
Can you ready?
I'm ready.
You say, no, I don't understand that. Well, here it is. I'm not thinking in that. Here's the analogy. I'm thinking better. Okay, here's a better analogy. I'll leave you alone.
Okay, I'm so sorry.
No, you're fine. I totally, I've been there.
You always turn right first.
Random. Mine's ready. Ready for
How
another
about
one?
the Walter? Are you ready?
Ready.
Oh, it's not gonna work.
Oh.
I don't think so.
He knew who was gonna win last time. E5.
I'm learning this
No,
walk
Okay.
thing.
Oh.
All right,
Ready?
This robot is a robot Magellan.
That's good traction.
Like once you start going for it.
I know. You gotta be able to think.
And it comes back to him just like a faithful story.
Instead of thinking words, you gotta think.
Carl.
You need a specific can?
The camera's in front of me.
Yeah, well, I'll do more of the show and tell. So the
Does,
first, don't measure the first one. Yeah.
Does it matter?
No.
Oh, you got 3 contestants?
Yeah. Don't measure the-
Oh, yeah.
On one.
So this one has.
Mine's a great
this one has
idea.
DC motors, they're open loop.
We did that one, I remember.
I had
Years
to
ago.
long time power use
Years ago,
12
we had
volts,
a-
7 volts because you can't really run it on 5 volts from an Arduino. The other thing is that open loop, you want to run it slow when you're turning. And so running the TC motor slow doesn't work very well without an encoder. So this is my first one. So it's a flaw. So it works. It had to run real slow and then
No, I like my.
really fast. So I mean, it worked. What's that?
What is that? Is that using time of flight or?
Yeah. So simple time of flight sensor stuff. And that's old school Arduino. Then I used continuous rotation service from the wheel.
Your wife doing any music
So I
lately?
guess you can measure this.
She has a song that she
So this is
recorded.
official or not official?
Trying to
Uh,
do a
and
video
see
right
what it's
now.
like.
Love it.
Well, you get 3 tries.
Okay,
So
so
we're working on it.
You can have two.
We'll see.
You can have two
Process.
robots. basically, in the-
yeah, but the same problem with these.
I'm
they
using
generate
AI in my.
faster. So when you run them slow.
Yeah, but it seems like a lot of people are not really into AI.
You mean the motor?
Um,
Just
Some people are.
Yeah, the motors trying to
I know.
run them so they're slow. so
Yeah, they
That's
say,
what you're stealing from
And
other
this
people.
seems like.
well, they just don't think that it's creative enough.
What's
Let's see my video. You tell me if you think this is creative. This was from 200 cut.
It's a single.
It's over
file
here,
file.
so we don't need.
Oh,
All right. Let's go with one.
Next week.
oh,
That's that. So they run pretty fast, so there's good motors, but again, they just. This one
In
is,
that case, is it missing? It's missing the target because it's.
yeah, it's jittering around.
Too jittering.
And all these have an LED that will light up when it's.
Oh.
It's LED sticking out. So these are stronger continuous rotation standard signals. So.
You gonna do this? You gonna do this?
this is it.
It's can.
You think that, that's.
I mean, if you are, you are. If you're not, I'll show you the video.
Okay, yeah. I'd like to see it. Okay.
Nice.
Yes. You see this guy? I'll show you.
Yeah.
That is it.
Then come to next.
Yeah, you're on it.
It's, went over the.
This is why they get eyes in the.
What are you gonna do?
The buck law.
Yeah.
That's fine.
How do you want to?
Oh, so this is 200 clips.
Like just put it 1 foot.
Yeah, and I still gotta get the water.
Like the middle.
Yeah, you could do that.
And then perpendicular to
It's really
the.
distracting.
I'll figure it out.
How do you want it?
Yeah,
This is-
One at a time.
Has to rotate. Okay, ready? 1, 2, 3.
With me. Me. Oh, that's pretty cool. It's like MTV.
Flat.
Flat?
I like how it's all the way flat.
Yeah.
It's kind of cool. Yeah.
I can learn lots of.
Awesome, dude. Just for fun, let's put it way further away, because I know, like,
Yeah, how far does your stuff go?
just for like a fun one.
Or do you want to do 3?
Yeah, you get 3 tries.
You get 3 tries.
Yeah.
Well, I mean, I'm not gonna be
That was
faster
fun.
than yours.
Put down my coffee
This could be
somewhere.
second place.
Yeah, you just stick it on the side. Yeah.
That's next.
Yeah, and it depends on the angle, but you know, this whole thing is dependent on how far the robot has to turn.
That's your.
Do you turn the same way every time or you randomize?
No, it's random.
That's what I did.
So it is, you know, luck.
There's some luck, yep.
Not here.
Oh, you're
I
confused.
learned a long time ago not to stress out about stuff.
Yeah, it might be.
I try to remind myself
Like
of
this.
that all the time.
Well, keep working.
Right?
But I have a lot of redundancy in there. So because I'm having to, because the sensors, your angle gets kind of, there's only one sensor. So I have to put redundancy, and if it misses, then it backs up and it tries again. This especially works when it's further away.
Yeah, that's what I want to see.
Well, first we'll do one more. Yeah, because I did work on mostly between 2 and 3 feet. So the close ones I didn't do as much fine tuning.
Got it. Oh, that was right on the
Yeah,
money.
locked on.
The thing is, I didn't
Oh,
know that
like,
kind of using the bluff when I.
yeah, okay, that works. That was the fastest I did, The first one was the fastest. The which one? First one. Okay.
Because the first one, I'm lucky and it turned.
Oh, it turned the right way. See, there is luck involved. Sorry.
Yeah, just one as far as you think he can handle.
Yeah, I set it up for like.
To the wall.
Oh, will he confuse it with the wall?
No. No, he cancels, doesn't consider anything that far away.
But it's the same distance as.
It'll also as close as they can, right?
Oh, that can.
Yeah.
That's wall.
Oh, but it's 9 foot across this way I measured, so it's, if you're anywhere near just the middle, like.
Oh, really?
So stick him in the middle and then put the
Yeah.
can
Yeah.
further.
Yeah.
Yeah.
This is not a thing.
No. You want to,
Just go.
Yeah.
Strategy anyways.
Get it closer.
I have to find, I have to tune the angle sometimes, like when I move the robot around.
What kind of sensor do you say that is?
The ultrasonic.
Ultrasonic?
Yeah.
The same one that's like that.
It's actually quite accurate too. I measured it with youngsters. Yeah.
Yeah, I had good luck with that too.
Product. Where thing would go from your table to a special fridge and grab a beer or soda, whatever, and then bring it to your table. Right? Simplify everything.
Yeah.
Maybe go with fiducials.
That's, yeah,
Fiducials are easy.
we're trying that a while ago, right? I remember Dr. Bruce talking about using fiducials.
It's too bad Dr. Bruce and his buddy there. What's his name? Brown? Alex Brown?
Oh, Alex, yeah.
Either one of them.
He's okay. Yeah. Well, he had other hobbies too.
Race other hobbies. Race
Oh,
car,
and train, wasn't he the train guy? Oh, no, the other guy was the train guy.
I don't remember, but he did have like the race car driver. They worked on a race car.
Should be a problem.
But the Bruce kind of lost interest after his operation.
He only had a surgery.
Yeah, big heart.
Yeah, if it thinks it screwed up, it tries again. But now it.
Yeah, I kind of miss those two guys. They were in the club for the longest time.
Yeah.
Or the woodwork.
That's cool, dude.
All right, sorry. All right.
MJ. Okay.
Yank.
Okay.
Do you have your own can or do you need?
Okay, but it's
I'm
safe.
trying
It's,
one more time.
it's fine.
Whatever can you want.
Do you need a minute?
You worked at your last or no?
Walter, are you ready?
One more test.
Well, hold on 1 second. I'll let you know.
Not yet.
Not yet.
Is it the
No,
new app?
it's not gonna work.
That's it.
Take a look at that.
I think you're up. Ellen.
Not that I'm gonna see anything this way. It's a little bit of that, like I said, they did.
It may not work outside of my Wi-Fi. I'm,
Okay.
Sure.
It's really tiny.
Oh, really?
Ready?
I'm gonna go back.
I could, but I really want to see the one professor.
Walker?
I'm out, yeah.
Oh. Alan?
Decided not to detect it.
Alan?
Alan's struggling against it. Maybe Wi-Fi issues.
Yeah.
So that, those are the only contested levels, ones, right, Walker?
Maybe it'll run it.
Do it afterward. Longer range, until time.
You can't resist, right? You cannot
Just
resist.
So Walter,
Incredible?
so you say you had it working and then you overwrote the code, is that what happened?
Now it doesn't even like.
I can do an official test and tune it.
Huh?
I can do an official test and tune it up. Or just give it a try.
Danny will put the
Yeah, so we're gonna do 1 foot.
Yeah, code is easier. It's easier to say.
Yeah, you started?
Yeah. It's kind of weird because you have to like.
It's too high.
You can't go back to some sort of.
Yes.
Said hard. We don't.
This was done.
Oh.
I've already told him, Professor Perkina, I'm played.
Oh, God.
Please.
Let's
kick in.
Translate.
Hey.
Because you got checked again. Go try it again.
You get 3 tries.
Yeah, rubber band and you put it there, might grip better, so that's slippery. Just put a rubber band around the arm and it'll hold it.
Maybe a rubber band?
Like, I know.
Thanks.
Brian has a lot.
I think it'll, I don't know if it'll close this up much, but it might have a.
Wrap it around one clock. Just around 1 clock.
Yeah. Okay. So anything not put in. Why they go over? What's easy is like.
It's not grip to hold it.
It takes. I already go about find a can.
I should really like
you know,
cloth
and have-
designs. I was gonna shoot it 4 years like that.
I convert it to little spacers.
This will work.
It should be fine. It should be fine.
Yep.
Really cool.
That's not.
It doesn't think it's close enough, so he's trying to.
Then recommend
like bring it closer.
Is that real wheel drive? Or all four-wheel?
All 4 wheels.
If I had it on the drive, I could have pulled it down and I backed up.
Everything I do.
But thankfully I have. So.
You
it's
do
not
have-
like
Put your hand in
I-
front so it takes close enough.
That was faster than the last one. You want to go one more?
Sure.
Last try. That was the fastest one.
Same orientation or?
Yeah.
I was gonna play, I had a gig.
Oh, you mean? That you call students.
Oh, that's my.
My new thing.
I got sent to us.
What did you have a band?
Yeah, I-
Yay.
Nice.
Yeah,
You want me to keep my hand here or?
I think you might be last.
Just, can you do it one more time, and I'm gonna stick this thing right in front of its eyes to trick it. I'm just curious if it'll do it.
It's one of the, I reverted back to another.
Yeah, like, that's fine.
So.
Yeah.
That's one thing that sounds like Westworld.
First, yeah. You know what it is, you might want floating point numbers for you. That's what I see doing.
Yeah, so it's
Yeah, it needs it needs close enough.
Yeah, because it's, okay, so I'm wondering why it triggers sometimes after a few steps. Because I know, like when it moves forward, it messes with the time of flight on the first pull. But then, I don't know why it takes several pulses for that to kick in.
What is the trigger for close?
It's a very shiny ground. Some of the storms are getting deflected out to the side, so some of them don't come back exactly right. You don't get the full. It would probably work better if it had like a little flat spot on the can or something. Yeah, it's. You did good. Yeah, up the amount of checks from what you had it set to, Professor, but it also made the rest of it slower to up the. You did. Your fastest time was good enough to take third. Or let me see. No, fourth. And Alan, he's not gonna. You're not gonna.
Let's try.
Yeah, let's give it a shot.
Do it.
Alfie.
I really hope this works. Yeah, I'm excited to see it.
All right, so
I'm very hopeful.
Thank you.
Very hopeful.
So the one almost success you saw was build 9. I'm not convinced I captured the commit for build 9, so we'll see what it does.
Well, do you want it inside or?
No, yeah, we're in standard context.
I know, I have to find it. I would capture it.
I think for this one, we just give it some handicaps, like put it right in front of its hand.
You? That's where everyone's doing it.
It worked. Want to tweak something. Yeah, but I mean,
Trying with all this backlight and people and all that stuff is gonna might mess it up. See, yeah, you don't know how to think through. It's always a mystery where they are.
All right, that's easy. It was a bust. I'm sorry, I can't get the server to communicate.
What about you?
No, it's, yeah. All right, sorry about that, guys. The best we got. The participation trophy, hopefully it'll work better next month.
You do your try. All right, guys. Back inside and figure out.
Yeah, we probably do that. Okay, what if you guys want for a I was on.
Hey guys, group picture outside. Group picture outside.
You have to hold your robot.
I like that.
No, like. Yeah, like a single baby, like a Lion King.
Exactly, it's gonna look like, you gotta wipe stuff on his forehead. A couple of weeks, I was wearing a Greek, okay, you guys kind of look Greek, so you can. Play the tackle.
Something saying.
Get that working ever, but way beyond the world.
Oh, I don't know about that. I just want to see it work at all. The wild card was when I had to run the model on another box. That's what throws everything for a loop.
Well, I pulled out my Bucketbot with a PC and quickly determined, like I used Roborealm with fiducials. I could easily have done that, but it didn't. Detecting a can using old school machine vision is tricky. So I would have wanted to use YOLO, so I didn't have the time to figure out how to train YOLO and use it.
You'd have to fine tune it. It shows cans out of the box.
Yeah, so I need to.
Yeah.
That's for the.
Are you
level
looking at the
3.
humanoids or is this? Oh, I'm not quite ready to pull the trigger on one yet. The Neo one is very tempting. So I'm hoping this buys me another year before I have to. Yeah.
Not quite a big.
Are you gonna buy a humanoid?
Oh yeah, eventually. I mean, aren't we all?
So when they can do something more.
That's a silly question.
That's the fun thing.
That's the thing, yeah. Data. It's all about collecting the data. That's why the 1X folks are getting them out basically for free or at a loss. Because once they're in homes, they can start really collecting
Back in the day, then.
all this amounts of real world. While they catch up on some other things. This staff executes behaviors, but it doesn't do the higher level thinking. They still have an AI agent framework that is the brain, but then that commands the brain to execute the behavior. That's the current staff. So, yeah.
It's one way to do it, I think.
Closer than you think, my friend.
They keep saying, oh, it's just a few months away, just a few months away, and it's like, no, I think it's many years away.
You need to do it for all this time.
But I have a useful humanoid robot.
Oh, at least you enjoying him?
That's a congrats.
Video.
Yeah, so we can go up like. And the link, it took some tuning tools. Click there.
Yeah.
And so if you use the same, fix the output, which is stalls. So I've got like, show and tell us about the robots.
Yeah, so I am hoping that everyone is a couple of minutes.
Okay, I want to try to.
But I can't force anyone to, but it seems like they're all here.
Well, I would sign up, yeah, just for.
Adding to the show and tell.
Little background. Are we gonna?
Yeah, let's break for lunch.
Oh, is it lunchtime? Yeah.
Okay.
We've got that done in exactly.
All right, so let's break for lunch now. Let's do like 45 minutes. So at 12:30-ish, let's come back. Okay. And after that, we'll announce the winners and who did what. And then after that, we'll do the show and tell, starting off with the contestants.
Oh.
All right, everybody, welcome back. So congratulations to everybody that competed. This is the heart of the club when we get together and actually bring hardware and see how it works. I propose that for next meeting, we come up with new contests so we can continue the momentum we got today. This was a lot of fun, guys. Like we said, we're going to start off with the presentations from the ones that competed. And so I checked out who got first, second, and whatever. So Brian, of course, there's no your fastest run was 2 seconds 65.
Got my goal now.
On second place, Carl with 8 seconds 54.
Oh.
And then third place, Jim Denuzio with a 10:83 because he got lucky and it was on that stuff. And then Jim Ubertetsing, 11 seconds 51.
Next, it was Bob with a 2082.
One in hand, so yeah.
And of course, MJ with a respectable 2332. Congratulations, everybody. Everybody did great. So, Brian, you ready to do your show and tell?
I don't know. So I presented this last time, right? I'll get up there.
So just tell us
And so what would you guys like to hear about?
that your development of how does it work?
It's got a lot of stuff inside of it. It's got encoder motors. It's got a gyro. It uses PID feedbacks. And probably the biggest thing I did was apply braking. So if you want to go fast, you got to slow down. And so I spent probably the last month trying to apply braking. And it was harder than I thought. So you want to go fast, you want to wrap up, go to as fast as you can. You want to slow down as fast as you can. Okay.
It's right where you're at. Sorry, there's a.
Yep.
Okay, good. I just wanted to make sure we weren't muted because that was.
Okay.
Sorry about that.
So anyways, that was more problem than I thought. So it would, like go and then oscillate, or maybe go back, go forth, go back. It would overshoot, undershoot. So like probably a lot of tuning inside of it. A lot of people are interested in these things. These are time of flight sensors. So they shoot out, I think it's infrared. They see how long it takes to come back. It turns out these are actually more complicated than, like everything's more complicated than you think. Inside, they've got 64 sensors each, but they report back one number. So they're I²C. To get 3 of them, I have to turn one on, set its address, turn the second one on, set its address, because otherwise they have conflicting addresses. And then they were shooting up too much or shooting down too much. I was able to go in and change the code on them. So each one has like settings or whatever. So out of the 64 sensors, use these sensors. So this was pointing a little more at the ground. This was a little more at the sky. So I narrowed the 15-degree field of view a little bit so they can see straight. Otherwise it is kind of a general purpose. I can swap out this top and put a flat top. I put a camera top later and stuff like that. It's ESP32. It's a pretty basic, cheap electronics inside of it. So that's it.
And 100% 3D printed.
Yeah, my proudest thing, and I think new people, that I designed and printed these tracks in place. And it's very, very satisfying to have tracks. So yeah. All right. Thanks, guys.
Okay, I have next is Carl.
So my design goal was low cost, old school robots. I ended up building 3. Let's see. So the sensor is a single time of flight sensor. So that was the one sort of not old school, like, ultrasound and all that. I think it's got a 25-degree field of view. There's different sensors have different fields of view. I didn't have the array. So
No, I think it's the same. BL53 or something like that.
53.7C. Yeah. Oh, okay. I thought there was just one in there.
Inside, there's a bunch, but it only gives you one number back. But you can fiddle with it.
Yeah. So if I can pass this around, you can look at it. But Mike Wimble ran into this, and then you ran into it. So I printed a bracket because on the kitchen floor it was fine, and then when I put it on a rough table, like because I was like bending over too much, reaching the floor, the rough table reflected back more. So basically, since there's a field of view on that sensor, that bracket just tilts it a little bit to try to get it so it's kind of the bottom edge of that sensor is flush. So all of them have these little brackets. Yeah. So I started with the TT motors, really popular, low cost, a couple bucks because I was trying to keep it low price. I've had several bad experiences with skid steer, and skid steer is like the 4 wheels, and there's a lot of friction when you turn. So the treads are a form of skid steer. This outside environment, that smooth floor is great for the skid steer. But I've built somewhere you put it down on the rug and it won't turn. It's just that you can't push the wheel sideways enough. And there's like optimal for skid steer, optimal distances between the wheels, and all like if they're far apart, there's more friction. So the closer they are, the better. That base is actually Ackerman steering because the front wheels turn. So that's like a car steer.
So Carl, this one is skid steering, and to get past that issue, I put a little piece of captain's tape on the wheels, and that's what I ended up with.
Yeah. Differential.
The other challenge with the TT motors is you can add an encoder, but for this contest, you want to turn slowly until you see the can, unless you have like a camera or something like that. And so driving them slow is a problem unless you have encoders and you're doing PID feedback. So I ran these open loop, and I knew that was not going to be great. If I added encoders and ran PID, then you can run them slower and a lot more control, which is what you need for this contest. So that wasn't that great. And then I have a motor controller, it's the L293 motor controller, and then the CPU is just a Nano, an Arduino Nano, so it's like equivalent to an Uno, but I use these sensor shields, so you can just plug things in. So because of the board has all these wires, it's not as efficient use, but you can see in some of the others. So I'm going to plug the motor here, and then you can see I added an LED on all of them, so you can see the LED go on when the sensor is tripped. So, and this one is like about a meter. Getting in the right place here, so I can pass around, turn it on like that. So because the TT motors need like 7 volts to run, I couldn't really just run them off the 5 volts going through the Arduino. So there's a 12 volt to 7 volt thing, converter here, and then these batteries are great for robotics. This is a town cell, but it has a USB and a 12 volt output on it. So it's really great because you can have 12 volts and 5 volts at the same time. So that was the TT motor version, which I eventually abandoned. Is there questions? You can pass that around. And I'm going to leave it turned on, but not the motor, so you can play with the sensor. So, all right. So then the next phase was the one that I basically did in the contest, and this one has continuous standard size servos, and so they're much more powerful. They're much slower. Had a lot more control, and you can see it was just rock solid on seeking it out. They're not super fast, but otherwise it's really simple. And the nice thing about the servos is that you can see the wiring on the Uno. It's just like, with that IO shield, it's just, you just plug them all directly in. So there's no wires all over the place. So, and then the other thing is so we did a contest like this. You had to follow a line and pick up a can at the end of a line. And I built some complicated mechanism because back in the day, you just couldn't buy stuff with a strapping plastic and servos to tighten the loop and all that. But this claw I saw on Amazon, and it's just really perfect for grabbing a can. So it's just a kit you buy. It's laser cut, single servo. And then the lift mechanism is this 4-bar linkage here that has a servo that pulls it up, and I can pass it around. You can back drive the servo and see how it works. But previously I worked at an agricultural robotics company, and some of the prototypes of developing, we had to lift the cutting blades just a little bit off the ground to sort of follow the ground. And this was the mechanism I came up with for that robot, that 4-bar plate linkage.
It'll be in professional experience.
Yeah, well, that one I do. Yeah, so the rest is 3D printed. So, and then the last one. So I kind of like those servos, and then I thought, the problem with those is they're $20 each. So this, it's like getting a little. I wanted to keep it like under $50 or $40, and so I said, these are really common servos. They're mini servos, and they come with a wheel. And so I said, well, let me try one like that to see how it goes. And what I learned from that is that they run kind of fast. So they're good for certain applications. And this one, again, we want to turn real slow. So I had to run, the signals I sent, the servo signals were so low, they just had barely enough power to turn. And so it was a little bit more, it was a little bit less effective in terms of solving this contest. So now I could have maybe tuned it better and all that and tried to get it just right. But the way I was working with the robot, the whole design is to go up to the can, turn till you see the can, and then move towards the can. If you lose the can, turn the other way for just a little bit, and then start the turning thing again until you see it again. And that's the entire program. It's a very simple program that I ran. So anyway, so these sort of worked, but what I found is they were a little flaky. Like running at really low speed, sometimes they just don't turn at all. So I think you might have seen that out there. So if you're running at full speed, they're great. But they're super low cost. I mean, they're $7 for a motor and a wheel. So that was a good deal. So anyway, so those are the 3. Any questions?
So I noticed on the first one you showed, you had it looked like a counterweight. Is it a counterweight on the top?
I just put that on because I didn't want to buy another claw. So I already had 2. So I put the weight because since I was doing just 2 drive motors and a caster on all of them. the claw was a huge front weight, and the battery provided the back weight. And so when I took away the claw, there wasn't enough weight on the wheels. So I put the weight on there just because I wanted to test just the time of flight sensor with the motors without the claw, just to, actually for demoing it here. Yep. Yeah, Ron?
Lower foliage.
I'm sorry?
For your lower foliage, you want it? You know, the chopper.
Yeah, I can use another circuit, but yeah, you can buy these voltage converters. They're yeah. Oh, right. Yes. So the one with the TT motors did have PWM. The problem is if you drive a motor down towards its lower limit, even with PWM, and I had the voltage up, I had 7.5 volts going in. It's not nearly as powerful. So so the PWM by itself sort of works, but there's a limit to it. Yeah. So but where the continuous servos, if you lower the signal down, they actually run a little bit slower. So that worked out. But even the smaller servos, when you drive them very slow, they don't have nearly as much power as they do when they're driving full speed.
You built these robots from scratch for specific composition?
Yeah, it's kind of. This is a support group. Yes, I'm a robot builder, and
He also mentors a lot of
an FRC team. But yeah, no, I've been doing this since I was in high school. Yeah, so.
How much did you have to you already had in your house or in your garage, and how much did you have to buy?
I bought all the motors, I had the batteries, and I had to bought the claws. So I should
about half of
try it. Yeah, I could have just done. Well, I had my robot where I looked for my robot from 20 years ago. I couldn't find it.
Oh, do you want to go with an old one?
All right, thanks.
All right, so Jim, you're up next.
You want me to go up there? Is that what the protocol is? Sure. Or can I do it?
You can do it from there.
Well, I guess maybe it's better to do that.
Well, it's close to the camera. I need to see the box.
Yeah. Instead of mine, yeah. So I decided to use the Lego Mindstorm NXT kit I already had, and I had already had a robot here for this contest, or it's not a contest at the club, but basically a self-ascribed contest to collect cans on the floor and just push them. And that was I called it Total Cans Recall, whatever. And so that was a different configuration. And for this robot, so now the NXT is a 20-year-old platform. This is from 2006, and it's pretty good even for today. It has motors that have PID and encoders and PID, so it's a closed loop system. The main difference is the software to programming environment is called Robot C, which came out, well, many years ago now, but for advanced roboticists to use, or advanced in the hobby world anyway, to use to program in C. And that is a great environment for, for more advanced projects on the Lego and VEX as well, if you're familiar with the old VEX. So what I did for this, I reconfigured it from the pushing robot that just had a claw, just had a kind of a plow, and it would push cans to this. I cribbed this design off of a book from Lego, and I just thought it was so cool. And in a hurry, I could, I didn't need to design my own claw. But what's cool about it is one motor can close the claws and raise it based on the friction. So when it's got this gear, I thought this was very innovative. Someone who's way better at mechanical engineering than me, is a little two flywheels that when the can is closed upon, a slight pressure causes the least weight of resistance, which is to bring it up. So I thought that was just too good not to use. The software I had written for that total cans recall, that one had to find the cans and push them all back to an area, a little 1 foot square area. So the software already had a full, what's called dead reckoning from odometry alone, which means since even these Lego motors know how many revolutions the tire is going as it's moving. So you can, with the math, with the fairly easy to look up algorithm, you can then keep track of where the robot's moving based on just the odometry. So, but that wasn't really necessary for this contest. But the other thing was that this is I started out with a sonar, ultrasonic, but ended up using this this time of flight IR, and this is a single point called the VL53LOX. That's what it's. But it says this is a single point.
Yeah.
It's definitely a single point according to the specs.
It returns a single point, but there's an array inside of it. It uses to give you that single point.
Oh, all right. Well, I don't know, but this just says it's anyway. It goes up to 2 meters, and I added a little tilt mechanism here as well because it tilts a tiny bit too low, you get the floor. Tiny bit high, you get the ceiling. And I worked on this to do a 3 foot maximum distance. So in this contest, we didn't use close to that. And at home, I did have it working a bit further than it did today, but it performed better than sonar ultrasonic as far as the distance. But tilt is a big issue when and the height here. I had to experiment with the height off the ground. At 2 centimeters was kind of too low. You had to point up, and at 8 centimeters too high, you had to point down and hit the floor. So there's this sweet spot that's under about 5 centimeters. And notice this robot has to approach from the behind, from backing up basically. Then it has to turn around. So there was a software complication there where I have to turn around and then go blind, forward. So when the robot's doing the final capture, it's totally based on only the data that it got prior to that, as far as the distance left.
How come you didn't put the sensor on the front?
And why I actually had the sensor up here. It was kind of difficult to fit. I had the sonar. I never put this one up, but the sonar was getting interference from there was no way I could, well, because of this action here, it was kind of difficult. I had to fit it behind this mechanical movement. And oh, by the way, it presses this button here to indicate when it's, that's how it knows when to stop. I had to put it behind here, and I just couldn't get, no matter what I did, it would have been too high. Like I said, the too high is bad. And then at the height I could manage, it was getting interference from the front of the robot. And it's not an easy way to get rid of that. So I'm like, somebody else had a design like this. In fact, the people that built this same robot called the Grab Bot, or not, this is sort of like the front end of this is from this example called the Grab Bot, but the rest of it is my own creation. Also 3D printed the parts I didn't have. So you can 3D print Legos whenever,
Legos.
What's that?
Non-canon Legos.
I know, non-canon. They're not as good, but I used ABS. Anyway, so yeah, that's why I couldn't put it in front, because I tried it. It did work, the sonar, but the distance was limited. So I could have just left it that like 4 weeks ago and probably done almost as good here, because we didn't go out to 2.5 feet. And I did my first recording on YouTube is of one with the sonar. So I ended up doing, I guess, two versions. So any questions about that whole system?
So on the Lego, when you buy them, you get like 4 sensors. How do you get a modified one to plug in? Does it only have switch, color?
Oh, good question.
Yeah.
Yeah, so I had acquired this. I didn't use this for this contest, but this is an IMU, and this is the TOF sensor, and they're both from this company called mindsensors.com. They've been around for years, and they're not cheap, but I mean, you know, they offer these third-party sensors for the Lego, and it's a lot easier than doing, I think, what Rob, the guy, one of our members was, would do his own sensor, and he called it Leguino or whatever, mixed Arduino and Lego. But it's so easy just to buy one of these, and it plugs in with, it's got the regular RJ, 45 or connector. And so yeah, Mind Sensors. So it's a good source, and it's been there for a long time.
Has to take the place of one of the other sensor defaults, like do you put it in the ultrasonic slot?
Oh no, I mean these are so you have 3 for motors and you have 4 for sensors, and as long as you have the driver software comes, and these 4 different sensor sockets essentially can be anything. You don't have to. You can assign whichever one to whatever sensor it is. That there's in Robot C.
Robot C.
Remember, I'm using Robot C. Robot C completely abstracts that. You can assign any sensor to any socket. So the Robot C is still a great learning environment. Any question?
I was just gonna ask which parts are Lego about, because I couldn't quite see, but you explained them.
Oh, not Lego brand. Yeah. That's pretty, plus my printed heathen prints. No. Yeah.
I was thinking maybe you could raise the claw up, so just like maybe raise the servo motor up on your like next revision, and then maybe move the time of flight sensor towards the bottom.
Or underneath?
Yeah, and then raise the general servo positioning up.
Yes.
To the middle servo, and then I think you might
Move this up, and then it could go. Yeah, it's possible. I had a lot more to do this last couple months, so I couldn't spend a huge amount of time. But it seems like a can is a very difficult thing to sight with any sensor, with any of these sensors, because it's a cylinder, and reflections from anywhere but the small section that has a normal pointing, a normal meaning a vector pointing directly back to you. Anywhere slightly off of that, you will not get a reflection. And so when you're moving your robot, I had to slow it down for this versus the sonar. Sonar is a bit mushy. It starts to get sound. That sound cone gets a response quicker than this a much finer. This is 25 degrees beam or something. So anyway, any other questions? All right.
Yeah.
Thank you.
All right, next up I have Sensei.
Could you raise up that screen so I can use the white phone?
He wants to. Jim, can you use the board right there on the right?
Sure.
That way we don't.
Make sure it's not permanent.
No, it's a dry erase permanent. Okay, my name is Jim Ubersetsig. I've been active in this organization for who knows how long, at least 20 years. Remember when we used to meet at Orange Coast College? Anyone remember that?
Fullerton, but
Before that, it was Orange Coast College. One day, Jess Jackson, who was one of our members, was demonstrating his robot outside the classroom on the sidewalk. And he was driving it around by remote control, and it hit the wall, and it made a hole in the wall. And he said, "Don't worry about it. I'll come back later today and patch the hole." And he did. And while he was patching the hole, one of the administrators was looking over his shoulder, and we never had a meeting there again. That's how we ended up. That's how we ended up at the University of California in Fullerton.
I didn't know that was outside. That was the outside.
He demonstrated it inside,
And then after the meeting was over, we were standing around outside,
That's
at
where
a sidewalk outside, and he drove it like right into the wall. Great big heavy robot. It looked like it was made out of quarter-inch aluminum plates.
It's kind of big. Yeah, it's a tail.
It may have, I don't know.
Anything like that.
You were there. Yeah, well, you were there. Yeah, you were there, yeah. Well, anyway, this robot has been built for autonomous robot contest, an amazing number of them. It still has at the bottom line following sensors for line following robots, black line on the floor. It has color sensing sensors. And okay, what I wanted to say about this is, for this contest, it does something a lot simpler. It just has one electric motor with a pair of gears to open and close the gripper, and another one uses a 4-bar linkage to raise this up and down. This piece of bent sheet metal is from when I replaced the water heater at my house. When you replace the water heater, they have some regulation that you have to put a sheet metal strap around it that attaches to 2x4 studs. So I bought that at the store. It comes in a big coil, and I had this much left over. So naturally that goes into the robot to hold the sensor in place. This is a distance measuring sensor, and it stares out more or less between the jaws and slightly above, just measuring distances. Now, the thing about that is, I designed it in such a way, looking down from above, here's the robot with its two portions of the gripper. The sensor is set in place so that it's slightly off center. It actually looks along a little bit like that. And it's very narrow beam width. It won't see anything either side of that. So I have the robot turn around this way until it notices there's something there, which would be the soda can. Then the robot switches and drives straight forward. Now, when the robot drives straight forward, say to here, sensor now being here, it now doesn't see the soda can. So it switches back to the mode of rotating again. Until by rotating, it does. So when you watch the robot going toward the soda can, it's going switching between the two modes. When it gets close enough and measures this distance, indicates the soda can is in here, it closes the hand. So that's how I'm doing that with one sensor. Well, that's all I have to say. Any questions? No?
All right, thanks, Jimmy.
Bob, you're up.
Well, forgive me, I can't bring mine in. It's 30 pounds and I don't think it'll fit on the table. Anyway, the robot I have, I started out with a robot called Robo Scout, which was a radio controlled robot back in the 90s, late 90s. And so I took all the guts out and all I left was the drive motors and the neck. The neck still turns and all that stuff. So anyway, so then to put new parts in, I went to put in a Mega because I knew I was going to need a lot of I/O, which Mega has 56 I/O lines and 30, or is it 30, I think 15 analog input lines. So anyway, so the robot is composed of a voice, which is around 8 to 10 bits, and it's an old-fashioned analog, old-school analog voice synthesizer, which you have to give it, they call phonemes, I think it's called, where you give it sound effects, and then you put it like the word one, you wouldn't spell W-O, or it wouldn't be O-N-E, you do W-U-N in your graphic lettering, so it goes one, that kind of stuff. So anyway, that's the voice part of it, and then for the sensors, I have an inclinometer, 2 inclinometers on each elbow, which will bring up the arm as a given point, and I have it go up and then down because there's slop in the arms, and I want to have it a certain height so it doesn't, like you get you read like reflections off of things like what everybody's describing and different kinds of problems like that. So anyway, I also want to have the right height for the tall can, like what the can I had today was a little bit taller. And then also, then the other sensor I have is the ultrasonic sensor that's for distance. And then the last sensor I have is a Pixie camera, which is probably a 10-year-old camera that, how it works is it goes in through the Arduino, six or 8 pin connector, and it's a smart camera. I think it was developed by Carnegie Mellon students or something like that. It's a group of kids anyway at college that developed it. And what it has, the features it has X and Y on it. And I'm only using the X, which is for this direction. And what you do is you learn a profile, which is called a signature. And so you put a can in front of it, and it'll draw a rectangle, and you can give it 7 different colors. So if you had 7 different soda cans of different colors, you'll have 7 different rectangles all in the picture. And so you have to pick the signature for the particular color you want. So this one, in this case, I picked red, and that's why I was able to discover the red can. I've tried other colors for previous contests. But anyway, so that Pixie camera, anyway, you can get very accurate X motion to see where things are, and you can get it centered right on the money. And I didn't even mount it that great. I mounted it with electrical tape, and it's probably off by 1/4 of an inch either direction, but it doesn't matter. It just corrects itself, or I can just slide the camera a little bit one way or the other, and it goes right to the can. And so I don't know if you guys want to know more about the robot, but the left arm has 7 degrees of freedom, so it has more elbow motion than what our arms would have. And that's all servo driven on that side. The right side is linear motors for strength, so it can pick up the full soda can. And let's see. The RoboScout, by the way, when it was as a kit, all it had was little flappers here on the side, so it didn't really have any functionality. So I gave it real arms with aluminum and things with motors so that it could get all the angles I wanted to do. I don't know if that's everything about it. Let's see. I think that's everything I was going to say. Any questions on any of it?
No, it's just good to see him back in action.
Oh, yeah. Yeah, it's more work getting it running again because I had to spend probably 15 to 20 hours just getting it to steer right. Oh, that's the other thing I was going to mention. So I had to change the belts inside of it. Okay, it's got like rubber band belts about that big or so. So they're circular belts, and they go bad after like 5 to 8 years. So then when I put the new belts in, it started to veer like this a little bit sideways. So then what I had to do, I had 1 bit left over that was pulse width modulation. I put it on this wheel so that I could control the speed so I could go straight rather than having it veer like that. So it's not a digital on off. It's pulse width on this leg, and this leg is normal on off. So it's, I think they call it asymmetrical proportional control is the terminology they use for how it's going. So anyway, it's a little convoluted, but that's all. I used up all the bits. So
your direct drive is slower than your absolute speed, we're good.
Yeah, that's right. So yeah. Anyway, I haven't put much time into it except in this last month just to get it to go straight. So that's kind of what makes it a little bit.
But you're talking about the mounting of the camera and the angle, but if it's not like when the camera sees it, you get back a box. You still have to. Are you turning? You make a correction.
Oh,
like,
yeah.
Okay.
Up.
How do you?
So when I look at the claw, let's say here's the can, and it's going like this. I'll just turn the camera a little bit that way, and now it's centered more. So if it was going to hit it like that and miss the can, I just tilt the camera a little bit more.
You got servo.
I'm manually adjusting it during the contest.
Okay. Yeah, you don't have servo on the camera, right?
No. Yeah, so I suppose I could put a servo on it, but I just mounted it with some electrical tape just to be able to get through the contest.
So you did manually line it so that it's pointing right in the middle of the claw.
Right in the middle of the claw, yeah. So even if it's off by a little bit, it'll still fall, the can will still fall inside.
You also did look like the robot was scanning and then it kind of made a correction to go back.
Yeah, so that's the asynchronous proportional steering. So what it is So yeah, what I tried out yesterday was, okay, put the can there, let it detect it. Now kind of move the can around, and I watched it all kind of follow it as I'm moving the can. Yeah, so it's really tracking it real time. It's,
But I mean,
yeah.
if it's still though, I thought I noticed it go past and then make a correction.
Okay, yeah, so the non-camera mode, I had it like blindfolded mode. So I was gonna bring a blindfold and put it over the top part. Yeah, so it's in sonar mode. So yeah, then it has to go back because it knows it passed up the can. Yeah, so yeah, it has like 2 or 3 modes of can contest built in it right now. So anyway, that's pretty much it.
MJ. Sure.
Hello, everyone. I'm MJ. I'm a student here at Cal State University Long Beach. Shout out to the engineering technology program. The most thorough practice I've had. Yeah, you're in there too. The most thorough practice I've had with the Arduino is from the lectures and labs that I took for the class. It had material from Martinez. It was taught by Sang. Professor Partida also teaches that same class also and lent me the design. I didn't make any hardware decisions. But I believe this is a Elegoo smart car kit.
Yeah, the base is an Elegoo smart card V5. It's the older version. Yeah,
I have a video.
and then I added the claw, the rest of that.
Yeah. So I took over the programming for it. The professor put in some code that showed me how the motor drivers worked, and from there it was a matter of putting in the routines for the behavior. This one uses an ultrasonic. With ultrasonic sensors, you have like this relatively huge detection cone compared to the lasers, and I borrowed this yesterday, and so I was like trying to come up with like what is the most robust way I could deal with that wide detection cone. And the way I dealt with it was just by cranking up the number of minimum detections like up and up and up. So that way, as soon as it even detects anything at the edge of the cone, that gives me I'll be for certain that it's at the edge of the cone, and then like adjust it just a teensy bit to go in there instead of having it detect it randomly within the cone itself. So instead of having the cone, it's just a line at the edge of the cone for the detection. That did have the ramification of, since I did it in discrete steps for the programming, it made having so much detections between them made it take pauses while in between each step of the program. But it's basically it had me kind of nostalgic for the class I was taking because it's like basically another lab, and this was a lot of fun to work on. Thank you, everyone.
All right. I had a comment on your.
Oh, okay. Go ahead.
I also worked on the sonar first, and then with this one, and I discovered for these both sensors that sweeping completely past the object was the best way for me, and I would collect the info and notice a minima or whatever. It's like a curve down like this, and then a minima, and then I would keep going until it went up again, and then take the middle value, and I'm keeping track of the angle, through my odometry. So then I go back to that angle, and that was kind of the method so it's like, it's interesting to look at the whole pattern of distances as you go completely by, and then there's one or two that are dead, like the lowest values. So that's like another way to do it. And I collect them in an array, like 25, whatever. Collect all the values in an array and then find the middle ones. And I'm keeping track of, again, of the angle the robot's facing. So I do have a heading. I'm keeping track of heading. So it does require more sophisticated localization code. But it's not that hard to do. And then your robot will be able to navigate for other contests.
Oh, yeah, that's very clever. I don't think this one has IMU or encoders on it.
It doesn't.
So
Yeah, it's just encoders.
Directly.
I didn't use the IMU, but just encoders for that. Yeah, if you get encoders, then you can do this kind of.
yeah, I could technically it's still possible with this design, but then you'd be tracking your map of your angles via like dead reckoning.
That's what I'm doing. Yeah, dead reckoning. But
So-
you need odometry though, at least.
So originally, when I started this one, I was using the sonar on a servo, and that way I could find the angle
Yeah.
because I was sweeping between 180 degrees,
Oh yeah.
and I could I could find the angle of where that servo was and go for that.
Although then you still have to make the robot go to an angle.
Well, it used the sonar to kind of guide it.
I see. To maximize to minimize the number. Yeah.
So-
This is a more sophisticated way. You
definitely.
don't need this, but it does help for more robustness. Because then you don't have a point of failure where it's not going to, there's no point. It's not going to succeed if this happens in the other case. Whereas if you have some navigation, then you can back up and try again and all that kind of.
All right. Awesome. Yeah. Right, Alan.
All right, so pride be darned. I think it's important to talk about when things work well and when they don't work well. So I wanted to just give you a little insight as to why Alfie positively failed. Now, even if things worked well, he probably was about a 50-50 shot. But the main thing that got in the way for today was the original game plan was to use onboard Orin for processing. Now, in the 4-hour retrospective of everything that's happened, there was a whole section on how that didn't work out well. But TLDR, the model's too big for that. So I ended up hosting the model on an overpriced, upgraded version of that, which is sitting on the desk here. Now, the reason he didn't do the behavior at all was because the Wi-Fi antennas aren't great on this, and he lost connection with the server out in the hallway. So as far as like why he didn't move at all, there's your after action report as to why that didn't work. So to briefly touch on what I'm going to do next. Now, obviously, I'm not going to buy an upgraded brain and not use him. So there's a whole Gen 2 hardware where that's going to be stuck on the robot, and there will no longer be any issues with the server communicating with the robot because the server will be the robot. The other two things that I think are ripe for exploration are that training FPS question from earlier. I think that if your maximum inference steps per second is 4, that your training should also be 4 so that your 16 item trajectory for actions matches that timing scale. Also, I'm curious about what's the minimum training steps to get a reasonable model. I don't want to wait 2.5 days every time I make a change. I'm hoping it's less than that. And so those are the things I'm going to do next. I'm also going to start on the rest of the Gen 2 hardware upgrades. And with any luck, my talk next month will be my redemption arc. So I'm getting a really good intuition as to why this didn't work well. I'm going to take all of that and feed it into a set of changes for the software side while I'm working on the Gen 2 hardware upgrades as well. So just wanted to share that. Sometimes the failures are as informative as successes, and this failed because of shoddy Wi-Fi.
Yeah, but you had successes on those last videos, which were
half the time at home.
Yeah, those yesterday, just the last couple of days.
We need to bring back the work at home.
Well, the videos are what really matters for your progress. you know, overall, because here's under stress in different situation. I mean, your basic progress, your videos show it. You know,
We'll get there.
So-
I just wanted to throw you.
The last contestant, Walter.
Work at home. Or don't change the code the minute before you go.
And that I've learned that the hard way.
I wanted to make it faster, but then I screwed everything up.
As usual. But anyways, this is so I got my nephew this little kit. It's a Maker Block MBot Neo version 2. And it's pretty high quality. I think it's like $200, but on eBay you can get them brand new for like about $80. So it's pretty complete. I mean, it's got an ESP32 processor in there. That's a dual core, 240 megahertz. It's really nice. Built-in battery charger and battery, lithium battery. It's got a new version of the sonar sensors that everybody's using. And one thing I noticed, I'm really experimenting with it. I wanted to learn the Blockly coding method. You know, it's kind of weird, but it's nice. But I noticed that there was a function for this sonar to actually focus on when you found something in the center of the sonar. So that's pretty cool. So that's pretty useful for something like this. Yeah, exactly. So I thought I was going to make use of that. And then I figured out how to add servos and just, 3D printed and created a little claw system. But it's nice. It's got an aluminum base, line follower, some really nice motors with encoders. And another cool thing about it is that this piece pops out and it's an LCD with a joystick, and you can make video games for it. And you can actually play games with it. It's got its own little battery and everything. So it's just a cool overall kit to do something like this. So I thought it would be fun. I had plenty of time to do it, but of course I was lazy and just kind of I had plenty of time to do a really good job, but I didn't. So, but anyways, just to give you a quick view of something here. It's got a nice LCD, by the way, but you can program a whole bunch of versions of your code also, and you can look through the menu and play the code that you want, which is just what I should have done instead of overwriting my main code. Should have had a bunch of versions of it. But anyways, so you can start. It says, RSSC can do, and it was going to go look for the can, and it even shows you how far it is from the can, and it would find the can. And it would say, and it would say, it got the can on the screen, and then I would be like, yeah, I'm happy, I made it, blah, blah, blah. But anyways, it didn't work out as I expected. But just wanted to show you that the kit is pretty cool, and that this is a little thing that can come out.
That is
And and then you can just make a game, and you can play video games with it.
You can drive them around and probably drive them around.
No, because this is the brains of it.
Oh,
the ESP sits in here. Yeah. Yeah, I know. No. You can't. You can't.
Does it have Bluetooth too?
Bluetooth and Wi-Fi. Yeah, you can use a phone.
You can use your phone.
Yeah, you can use your phone if you wanted to, but
does it have a Bluetooth app on the phone? Or?
It does. Yes, it does. Yeah, yeah. It's got a whole ecosystem. It's got its own IDE and everything. It's really nice. I mean, it's very well made. The quality is, you can't go wrong with it. The quality is really good.
Well worth it.
Yes, I agree. It's a lot for $80. And the quality, like I can tell, the motor, everything is.
Can I see the box?
Yeah.
We use that same kit for we set up a summer camp for Boy Scouts for a robotics merit badge, and that's a very durable kit. And we've taken it apart probably 5 times every summer, and it's 5 years old, so it's been dismantled by kids tons of times, and it's still holding up. It's very durable if you ever want to use it for a summer camp.
Oh, good. Okay. Yeah, I mean, aluminum, I mean, everything is, I just think it has a lot. If you're going to buy the components by yourself, it's going to be way more than that. And it's going to be not as nice.
Prices are like $122 delivered.
Yeah. Yeah, they'll find it for 80 brand new. They'll pop up from time to time.
Yeah, maybe it's, yeah, you have to wait for the really good first.
But I want to show you this real quick. This little, I got curious as to how did they make this little guy, like a little dog, but how did they make it go left to right, you know, and do all these tricks? A single leg, yeah, a single peg per leg, yeah.
Somewhere.
Oh, is it? I don't know. Amazon, $30. Really, really good. But it's got a remote with 16 different functions in there. And I mean, you can make it, you know, you can make it go left, right? Oh, that's nothing. What? A little dances? See? A little say hi. Don't even sit up. Check this out. Check this out. Watch this. I know. Those push-ups. One-handed push-ups. That's impressive right there. I'll do a little kung fu. Anyways, I was just impressed with how would they do that. So I'm gonna build like a miniature one with the tiniest motors I can find with just this little 4 legs. Do you have an explanation of how it's able to walk with just the 4 joints? I don't. You know,
Noticing the one leg raises or that's
yeah.
my work, but it's working great.
It is called Rapid Power Mini Remote Control Pet.
How much was it?
I think it's like $32 on Amazon. It's Rapid Power Mini Remote Control Pet.
And how hackable is that? Can you?
It's very hackable. I already opened it up and everything. It's got some really nice motors with encoders. So there's something they're doing some or encoders or just regular potentiometers. I'm not sure, but it's yeah, it's pretty impressive.
Yeah. I love it.
They just do it. That's me. Yeah. Rapid Power. Yeah. Rapid Power Mini Remote.
I didn't see it on Amazon.
No, I went to eBay since I was already on eBay.
Oh. Yeah,
Rapid Power
I got it from Amazon though, but yeah, recently I just got it recently.
$28,
28, yeah.
$6 shipping.
Send me the link.
It's impressive for what it can do. So I'm gonna try to replicate it, but in a miniature one day. That's my goal. Anyway, it's just fun things to. Exactly, it's fun. Yeah.
Thank you, Walter.
Thank you. Yeah.
All right, those were the contestants of today's robot challenge. Now we're gonna go on to the online show and tells. Starting off with Ross. Ross, you ready?
Sure. Welcome to the calling in from the north.
Oh, there you are. Let me put your volume up.
Good. What I have is a bald-faced promotion for the book that some of you have heard. A bunch of us have been working on for the last few months, and it is now for sale. This, as many of you have heard, there's 5 of us have collaborated to each of us build a variant of a smart table, led by our indomitable leader, Camp, and Alan, me, Phil, and Thomas. It's tells you how to build all the code and all kinds of ideas to customize it to make it do what you want it to do. We have mostly a good deal of fun putting it together, and each of us have been able to produce something that navigates and runs around the basement and lets us try out different aspects of building a robot: batteries, camera, RP LiDAR, and so on. This is my version. called Turtletron, which which was probably my first, probably the first thing I used a couple of years ago, AI for, was to come up with the name. And so this is Turtletron, based on the base that was released as a TurtleBot about 15 years ago. Back in the, I guess, back in the days when things were easier to do or harder, depending on your point of view. And I was able to get a replacement battery for it and went ahead and used lots of code that's available from lots of the folks that are online today and in the forums onto a Raspberry Pi 5, and there we are. The code is the code of my robot, plus the other three are posted in each of our own GitHubs. So if you want to have fun, try out something that uses a base that you may have in the back of a cupboard someplace, or you know of a friend who bought a bot vac and didn't use it. There's a perfect good way to use it. But there we are. I hope whoever goes ahead and uses some of the material in the book, I hope you enjoy it, and you certainly, as it was the case with each of us, we've had a great learning experience with putting it together, and mostly getting together once a week working on the book itself. So.
All right.
And right here, Ross, this is with Ross 2 and one of the latest Ross 2 varieties.
Yeah, yes, Rust 2 Jazzy.
Jazzy. Right.
Correct. And we all use the Raspberry Pi 5, but Raspberry Pi 4 will work.
5 and 4. Okay. And if you have a Nito botvac base already.
Yes. Yeah, Camp's it should be of no surprise to anybody that knows Camp. He's kind of the Nito person around here. His variants use the Nito base, correct? And actually with Camp's robot design, you actually get, I guess, 4 for the price of 1. He also has description and code and ideas on using the Create 3. So the answer to your question, sorry, is he's good. He's included both a botvac implementation and a Create 3.
Okay, so next you guys gonna
And a Roomba too.
a Roomba.
Yeah.
Next you're gonna put an arm on it, right? You're gonna do a full manipulating robot with using the Move It. Is that a good goal?
I've actually got one up on the shelf behind me here, and that seems like a good project. I'm not so sure I'm not so sure I have the 2 lifetime that's probably required to implement all of that, but it's a good challenge.
We've got Claude code now, so and a team of people.
Anyway, I have to say, when I'm finished with today here, I'm all packed and I'm heading off on the airplane to San Jose and Monterey tomorrow. So I will be enjoying hopefully nice California weather for a couple of weeks coming up. Not as far as LA, but
Tuesday's rain.
Yeah, I will think of all of you when I'm having lunch, hopefully in Nepenthes. And for anybody that has been there, you know what I mean.
Far north.
Far north from you guys, not as far as where I live, but further north. Yeah.
You're far north.
All right, any other questions?
Anyway, thanks. It's always great to call in and see the clever and great work that all you guys contribute to building robots.
Thank you, Ross.
It's always good to see you.
With a little luck, next month, I'll bring in my mock bot. I have a mock bot.
All right, I'm looking forward to that. Okay, next on the list, we have Zachary. And remember earlier at the beginning of the meeting, I talked to you guys about the UCLA Relay for Life event that they are having. Zachary, do you want to tell us more?
Hi, are you able to hear me?
Yes.
Those were some very impressive presentations. A lot of it went over my head, but it was very nice to watch and listen to. My name is Zachary Kraus. I'm the recruitment chair for the American Cancer Society at UCLA, and I'm here to tell you about our biggest event of the year, which is Relay for Life. It's a 12-hour event that's held at the Drake Stadium, which is our track and field stadium. It goes from 12 p.m. to 12 a.m. on May 16th. It features competitions, food, live music, ceremonies, a runway pageant, a 5K race, a silent rave, and much more. Last year, we even had a mechanical surfboard to ride. And this year, one of our events that we want to host is a robotics competition in line with this year's theme, which is Formula One racing. So all the money that is raised at our event goes to supporting cancer research and patient care, which includes transportation to and from the hospital and hope lodges for a family to stay nearby patients receiving care. And yeah, so anyone that registers for Relay for Life is able to compete in our competition as an individual or as a team, which is going to consist of a qualifier 100-meter race around the track. And then from that qualifier round, we'll do a final round, another race to win trophies and other prizes. Additionally, we're going to have an audience vote for the most stylish robot for an additional prize. We will provide timers, referees, an announcer, and a large audience for the event. Last year, we had over 200 people registered. And additionally, registering for Relay includes a free t-shirt and lunch and dinner for the event. The registration fee is $25, but it's $5 off any Tuesday in February if you want to register now. And then in terms of the competition, to protect the safety of our track, we are going to require rubber or plastic wheels, battery powered, a maximum weight of 100 pounds with a built-in kill switch, and no spikes or sharp edges in direct contact with the track. So I would love to see any of you there, and let me know if you have any questions or feedback about our event.
Zachary, can you tell us, like, how is the race supposed to be? Is it a relay, like a team where one robot meets another one and the other one continues, or is it just one robot going really fast around the track? Or
Yeah, it's currently planned to be each team or individual enters one robot, and like so it's on a track field, so we're gonna have 8 lanes, and each robot will have its own lane. It's just gonna be a straightaway finish.
fully autonomous?
Um, it can be autonomous or controlled.
Oh.
Do you have different? Do you have different rates for autonomous, or is and controlled, or is it mixed?
That would be very different.
Right. Are you going to have different races for each category?
Yeah, we'll have different races for each category.
If there's enough autonomous ones.
Yeah.
So the robot will have to complete one whole lap?
No, he said a straightaway.
100 meters.
Like a small.
Oh, okay.
Just drag
Yeah,
race.
just 100 meters.
Wow.
So,
100 meters.
No, that's not small amount.
Okay.
This thing couldn't do 100. Oh.
That's awesome.
It sounds like fun. Sounds like a lot.
Where's it gonna be?
UCLA.
UCLA and
The link is in the chat.
May 16th.
And when's the day again?
May 16th.
May 16th. Okay, there's some time.
Although we have.
Yeah, I just curious, are there official like rules or guidelines posted? So, because if we're building something, we build exactly to a spec. So if it
There are
is it written
guidelines.
down
You have
somewhere
guidelines?
like
Got guidelines up on the web yet?
We have not posted on the website, but I can get that done soon. And as always, feel free to reach out to me. I'll drop my personal phone number and my email address in the chat. So if you have any questions, and then I will get that posted.
So are drones allowed?
On the ground.
That's on the ground.
That's it.
Yeah. It has to be in contact with the ground.
Okay, so you mentioned wheeled robots. How about leg robots?
He said wheel, that's why it has to. Oh, I.
So you mentioned wheeled robot, but what about like a quadruped, like a dog? You call them.
I think that would be okay. As long as it's like not metal, it's gonna have to be rubber or plastic.
The
feet.
I can deal with that. All right, and then drones, nothing touches the ground at all. So.
Yeah, and it's interesting, you had to control it, you could just run it down the track, that'd be kind of cool.
Yeah, I think we can probably hit 120 in 100 meters.
Second?
120 miles per hour.
No, I think 120 seconds.
Okay, go back.
No.
The speed drones?
Oh, drone, I think you're talking about your dog.
No.
Oh, yeah,
He said no
drones will go real fast.
Wait, did he? Did you say hard going?
The wheels have to touch the ground.
Well, what if it starts on the ground? Okay, so here's the thing, you're in a room with a bunch of type A overachiever super nerds who will optimize any solution for the available rules. And it sounds like we're joking, but we're honestly trying to figure out how to beat each other.
Is it okay if the robot hops?
I mean, it's just advanced walking, so I'd say, yeah.
So here, maybe we could do this. Get, as soon as you get the first set of rules, we'll continue to work with you to find loopholes. Until we're all satisfied with the ground. 100% serious.
What was the date on that?
May 16th. Yeah, maybe email the rules here to help get it narrowed down. to
Okay.
rational.
I have a question. So, I mean, at that point, does it really have to even be a robot? Because I feel like there's like it's just a straightaway. You could just go buy like an RC car, like a hobby grade RC car at like a shop, and those go like there are ones that go like 150 miles per hour, and they do that in like 6 seconds. So
Gotta stay on the lane though.
true.
Yeah, it's
That's
only
true.
the driver.
That's true.
But he said that there's gonna be categories, so maybe there's a remote control category and then the fully autonomous ones. So
That may be the autonomous ones.
we're interested in the autonomous one.
I think the remote control one is just going to be dominated by RC cars.
Yeah. People are really good at making this go fast.
The races are all in San Diego or whatever, remember?
That's pretty interesting.
All right, so Zach, can you post the rules and all the requirements and all that stuff?
I'm gonna get
maybe send us a link. You can send it to me on my email, and I'll forward it to the rest of the group.
Before you go, I have one more question. That picture behind you, is that the track with that bright blue and the nice white marks?
Yeah. So yeah, this was a picture from our event last year.
We can expect it to look kind of like that.
Yeah, so we can use those lines as guides.
Runner's track.
Yeah, but
Yeah, exactly.
white lines.
That's a runner, like a.
It's a track.
Line following
It's
on the track.
It's a sports track.
Yeah, like following on the track.
I mean, that's basically a donkey car. It's been optimized to do that for years.
No, this is a drag race.
Yeah.
Jockey cars optimized for the Derby track.
Oh,
It's
you're
a
right.
drag
Well,
race.
I meant just in general, going
Yeah.
between two lines.
Yeah, and I prefer to optimize for loopholes in the rules, so let's see what we got.
Oh, you mean rule number 1, interest shall not be Alan.
Bam.
Yeah, will there be Wi-Fi?
All right, and it sounds good. You've piqued our interest. So we posted some links in the chat. Those links will also make it onto our forum. 100% honest truth. If you'd like an additional set of eyes, because you can see all the different directions people are thinking, safety you'd want to be first. So we would be happy to help you on rule generation to kind of balance safety with excitement and maximize revenue for a very important cause. And although I'm hearing a hard no on drones, maybe we can revisit that with the first set. We'll see where we end up. All right.
The state.
Rockets are okay though, right? Which one?
It's
Okay.
Yeah, explosions, like explosives,
As long as,
kinetic energy.
as long as it doesn't damage the track.
Okay, that's right. All right, Zach, thank you so much for taking the time to share this with us. It looks like a lot of fun, and hopefully we'll be in touch.
You piqued our interest.
Yeah, with your rules, you might want to consider whether you need a kill switch. It's called the dead man switch, where the person lets go of the remote. It
You
stops.
did say it requires a kill switch.
Oh, it already does. Okay.
Yeah. it requires
Well,
a
I mean, a dead man switch is where if you let go, it stops.
Yeah.
Not the other way around, not pressing stop.
Yeah.
That's a big difference.
Yeah, you're the first group I've met with, and you've definitely given me a lot of new information that I need to think about going into these things. I have one question. Would you prefer if it was a full lap around the track, meaning it would have to do turns?
No, the drive should be easier.
That's a long way.
Not many people could, a lot of
Quarter
people
mile.
do this,
Yeah.
less people could do this.
So, I'm sorry, yeah, we would prefer like a full lap, right, with turns.
Well,
Okay, it's fair.
What if we have more interest? Two categories, one for the full track for a few robots that might be able to make it, and then a lot of more people would do the shorter track. But it'd be
But you can add obstacles on the straight track, add some obstacles that they have to.
climb over.
You know, get around.
So the point is a fundraiser, right? This is a fun thing.
Here's a serious question. Can you guarantee there's no people on the track?
Yes.
Okay, good.
Yeah.
I've been in races where there's people mulling around and
Well,
that's
then that's
really,
they have to have the safety.
We saw a recent one in China where they had the drivers right behind and one person drove a humanoid right into another and knocked them all over.
Oh, yeah, that was.
good.
Yeah, you have to have safety at first, right?
The Robo games had people all over.
Yeah,
They follow you around.
Yeah.
which one, during which contest?
Magellan, Robo Magellan,
Yeah, but.
and all the contests, but most contests.
But those are usually ahead of you, you can't catch up and they're not gonna trip you.
The same.
Okay, so to recap, wheeled robots are okay, quadrupeds are okay, bipeds are probably okay, drones are out.
I don't know, I haven't seen the rules yet.
Okay,
All right.
maybe
Think about
I can think about making a drone category. I don't know.
I know,
Or
Spank this competition. I'm in it for the next one.
yes.
I don't know. I mean, I feel like the remote control part is just kind of like it can be exploited so easily. Like
Yes, but we're
Two separate categories. So
going for the autonomous.
the drag racers will have their race and then the robo nerds will have their race.
Full autonomous.
Yeah,
That's
so,
our.
yeah, so Zach, you have a point of contact. I think you're working directly with Ben. So if you're comfortable and would like a second set of eyes, we'd be happy to help weed out the
Allens.
loopholes.
Close the
Allens.
loopholes. Yeah.
And it'll be fun. I think it'll have fun. Anyway, you end up with the rules.
Yeah, I really appreciate that. I did put my phone number and email in the chat, and then I will also be in contact with Ben to talk about rules or anyone that's interested in talking about the rules, and then I'll send them out to everyone.
Sounds good, man. Thanks for taking the time. We appreciate you.
All right, have a great rest of your day and weekend.
We meet on the second Saturday of every month. If you want to come back and say hi, just nerd out on robots.
Aren't all of your events in Long Beach?
Yeah.
Yes. Our meetings. We occasionally do events like yours and maker fairs and that kind of stuff, but our monthly meetings are always here at the University of Long Beach. And of course, everything is live stream on Zoom.
Okay. All right. Well, happy Valentine's Day, everybody.
Thank you.
All right, you too. Thanks, Zach.
Bye.
Bye.
All right. So the next stop is Thomas.
Share my screen.
There we go.
All right, guys. So I've been diving into AI, maybe not as deeply as Alan here, but I've been diving in head first. And I found out that a lot of people here, well, they get about this far in and they go, well, I can't do it. I don't get it. It just doesn't make sense to me. So a lot of people came to me with those concerns when I started talking about AI. You know, I don't understand the thing you're saying, Thomas, because I've been teaching this stuff for a few months now, maybe a year. Anyway, so I put together this book. It's called The Very Gentle Introduction to LLM AI, Large Language Model. In other words, the ones like ChatGPT and Claude and Gemini. Because this is to bridge the people who have used AI and the people who are going right in and programming AI, like Alan, myself, and Jim, you others here. It gets you started at the very beginning. It teaches you the terms you need to know, and it's free. It's in 2 weeks, March 1st. That's a Sunday. Somebody check the calendar. I want to make sure that's the Sunday. Otherwise, my wife's going to shoot me.
The Sunday.
Okay, good. Thank you.
Yeah.
By me, Thomas Messerschmidt. You don't have to pronounce my name. You certainly don't have to spell it. That's confused people for years. Anyway, let me. Schmidt. Yeah, it's knife smith spelled a long way.
Just think of Messer, which is two. Yeah,
that means a knife.
And Schmidt is a common German stone.
Schmidt. Yes.
And
so the goal is to make LLM AI like ChatGPT and all that feel approachable for adults who are new to AI, but still learning. And to keep the tone friendly, define the terms as soon as we use them, and stick to practical examples you can use right away. Now, this is a seminar. This is going to be all day, Sunday, well, 4 hours anyway. You'll have plenty of time to set things up and ask lots of questions. If you like knowing how things work under the hood, you'll be right at home. By the end, you won't be just using AI. You'll understand what's happening enough to confidently use it. And also, you'll be able to program with AI in Python. You can add it to your own robots. That's the end goal of this. We're going to take you that little step further and get you programming the API. Everybody knows what an API is, Application Programming Interface. So you can connect your Python program to an AI model, all within a few lines of code. And this is going to happen 2 weeks from tomorrow.
Is this in person or online?
Online Zoom.
Oh, okay.
Free. No charge. And you get my book. Free. No charge. Any questions?
Do you have a synopsis or itinerary ready to kind of give a quick visual overview of?
Yeah, it came in the email I sent.
Oh, is it on? Is it? Do you want to put it on screen?
Yeah, I could. If I can find it. Could you pull it up? I'll stop the share. I sent it out like yesterday or something.
Oh, it's here. We'll cover blah blah blah. It's an email Friday 4:43.
Oh, do you want to bring it up on the screen?
Oh, sure.
Let me stop sharing. Yeah, zoom in on that.
We'll cover.
Okay.
Quick history of text generating software from the early chatbots to today's LLMs. The big idea behind LLMs, predicting the next piece of text, how they read and write, what an LLM knows and what knowing even means for the software, why they sometimes hallucinate, conversations, memory, personalization, agents and tools. How do you get your LLM to write your emails, to read your calendar? These are tools. Quick tour of popular AI software. A brief intro to AI beyond text. In other words, images, audio, video, multimodal. And we're all going to that with robotics, multimodal. It means many ways of doing it. a beginner-friendly intro to programming and LLM AI using the API with Python. And you don't need that much Python. I mean, that much Python will get you through this. Don't think you have to be an expert in Python. Besides, I'll be giving you the code. Any questions?
Is the expectation that people can follow along and run the code with you, or is it more of a lecture series?
They can follow along. There'll be questions and answers. I'll be asking them questions. They can ask me questions. The software is a small part of it. It's mostly a lecture with a little bit of coding at the very end. So it's fun. It'll answer your questions if you have them. It'll get you from where you are now as a user of AI to a programmer. Later on in the year, I'm going to do another seminar on how to build your own large language model AI. It's not that hard. I mean, they've mapped the path for us, so we just have to follow the trail. So if you're interested, send me an email through the mailing list, or come see me after the meeting, and I'll put you on the enrollment list. Okay, right now I've got about 10 people so far. I'm going to cut it off if we get together. That would be a little bit much for me. Any other questions before I'm done here? All right, thank you. All right.
Okay, that was the last show and tell. From now on, it's just open forum if anybody wants to say anything. Yes.
I have a brief topic. So we all did this kind of design. That was a lot of fun. And we're going to be thinking about what the next one looks like. And so which direction would people like it to go in? Like, I'd like to maybe
Talking about contest?
Yeah. What would you like?
I'm trying to get one of my robots working again. It's a navigation robot. And all we would need to do is localization. In other words, you put your robot somewhere on the floor in a room, and it would try to figure out where it is, maybe display that or in some way announce that.
And then go anywhere?
Well, the code that was in it when I took it out of this cardboard box did exactly that, but I'm trying to make the contest simpler by commenting out most of the code. So all it has to do is report where it is in the room. But if we want it to be navigation contest, I can add that back in.
But how would it know where it is in the room?
That would require like LiDAR or some kind of other.
Point A to point B autonomously, it really needs to know where the destination location is.
But you would need
right destination. But I mean, if it's just have a robot sitting there, you'd have. I mean, you mean scan the walls and know what the room looks like. You have to. Is the goal to make a map or?
I built it years ago. It has a scanner built.
Right. I mean, if for the contest, is it to like if you're in the corner of
any method that works?
So right, but what is the goal? Is it's like if it's
the goal is
exactly the goal.
I just added like an LCD display to it, so that it can say I'm so many inches from that wall, and say to the right or left by so much, like in rectangular coordinates.
So it's giving some kind of coordinate thing and telling you where the walls are.
I'm just going to report it in inches.
So if you put it
so
like
you can check it with a tape measure.
I see. So if you put it near the corner, it's supposed to say I'm, 20 inches from the wall to the right and 10 inches from the wall behind me.
Something like that.
So,
interesting.
That's a nice. So localization, maybe using localization is an idea. Another thing we're toying with is taking the existing, like we pick up a can, but we said we would go try to do something with the can as a future step.
That would make sense.
We could have, hey, take a few cans and put them in this square over here. That's the fun contest.
So that was similar to
stacking and stuff is also good. It's probably a lot harder and probably require physical modifications. And the other one is.
Well, I like your idea because this robot already has a line following, line detecting sensor at the bottom. So if we were to indicate the place where you put them by putting like a black line or something around it on the floor, it could probably do that.
Right. So like there's a few cans and there's a receptacle so marked by black lines and try to get them into that pit.
Yeah.
The last idea, and this some people like, especially like Jim's kind of thinking, is we could have some sort of AI involved. So if we want to have another level, you give it a command like put 3 of the cans in the square, or knock over, or do something with the Diet Coke can and not the regular Coke can. But we wouldn't tell you ahead of time, so it kind of encouraged the use of language models. So anyway, I want to put those out there. We don't have to answer, but like put those out there. What would you guys like to do? And what would you like? What would you get involved in? And what would make you excited to do the next contest?
I like the idea of iterations from this one. So everybody that competed today can just add a little more to their robots.
Yeah, we had big participation today. Sometimes we've had contests with 2 or 3, and with the number of people we have, if we have anything to do with distance and rolling and stuff like that, like even falling along the wall and coming back and going around the hallway, or something, a variation of today, that people already have the sensors, they have the wheels, and it's not a lot of modification.
Yeah, and I have to say I really like this one because of and this line, because manipulating the objects in the world is something a lot of us rover robots don't do that much, because it's like we're all with navigation stuff, and interacting with the world is a whole other category and difficulty. Manipulating objects, which is something that the contest kind of, it brings out. More contests have that than stuff you do like exercises.
So I'm thinking maybe even two tiers, and they could be different months. This marking out an area and getting things into an area sounds pretty complex, actually.
Yeah, that is similar to the total recant, call recant.
We called it throwing out the trash can.
Yeah. Okay, so, but that would use our existing hardware.
That was nice.
I'm in favor of that concept.
Okay.
Yeah, that was the one,
like you say.
where I push. I just push the cans. Remember those videos?
Right.
But now you need to lift them to get into the.
Even if they want to push them, that's okay too.
Yeah, that's okay, right. Because we don't want to make it hard. We want to have
grow
a
a little bit.
Okay. Innovation.
But that was a known contest where it's a 6-foot arena with a black line around it, a 1 foot by 2 foot area with black line, and you needed to go. The cans could be placed in that 6-foot arena somewhere. You collect them and bring them back to the.
So let's say maybe I'll even propose
that's one of them.
And maybe a second tier if you wanted to add a language kind of ability on top, so we could have that as an option.
Then you could say grab the red and the blue, but not the other one.
Right. So you could force it to be kind of reasoning and could get some of this. Okay, so
I like that idea.
You're combining.
Okay.
Right?
Okay, so I like that. Maybe we'll elaborate on it in the chats and stuff.
With the development.
That would be a really good, because our existing robots could target these skills.
We won't need a lot of building time either. And
Okay. That's what I wanted to, so that was it.
Okay. I like that idea.
Yeah, so let's start a dedicated forum thread for, we'll call it Can Do Part 2 or whatever we end up being, where we can kind of discuss with a goal of finalizing the rules next month with 3 months, maybe, depending on what we can do the contest. I like it. I'm in.
Let's do that. Okay, anybody else have anything else? All right, I guess we can call the meeting. Thank you everybody for coming and hanging out with us. We'll be here again next month on the second Saturday, and we'll do it all over again.
Not gonna say.
Never.
Oh. Okay. Are you ready? Are you ready?
Great.
And it's so affordable. People, they'll sell more of it. Yeah. Some of the stuff we get, we go to Vegas. Get all the size.
Thanks for coming. Walter. I came up with a mechanical contest.
I know, yeah, exactly. No.
Not bike race, you normally have bike race?
Yeah. No, yeah, I want to do the competition. I tried to.
I meant
real
we
quick.
did a lot. Like,
I didn't.
They always had something before.
No, I
But I mean,
I did.
yeah, it's like, I love it. I think I proposed like a Roman Magellan kind of thing, but nobody entered it was too hard.
Yeah,
So you gotta.
I like it because I already have so many thoughts running.
Yeah.
I showed him actually.